Hello. Okay, very good morning. Am I audible?
Yes.
Okay, on the second day, first session of our 3-day FDP, I, Shubhankar De, Assistant Professor of Civil Engineering Department, Global Institute of Science and Technology, welcomes you all for the first session of second day of our 3 days FDP. Today, for the first session, our eminent speaker, Mr. Tanmoy Ghorai, already joined. So here is the small introduction about our eminent speaker. Mr. Tanmoy Ghorai had completed his Masters in Civil Engineering in the year 2011 from Indian Institute of Technology, Kharagpur. Presently, he is holding a position of manager in design at Ampere Tech Solution Private Limited. He has over 9+ years of relevant industry experience in renewable energy and infrastructure domain across Asia and Europe. At Ampere Technology, Mr. Tanmoy Ghorai is involved in the project tech, due diligence and review of civil and structure design and drawing of solar PV components. Prior to tractable engineering, Mr. Tanmoy Ghorai has worked with one of the most renowned firm in water sector, that is DHI Water and Environment Private Limited, as a mathematical modeler. During his tenure with Tractable Engine, Brussels, Belgium, he was a probabilistic safety assessment engineer for Belgium nuclear power units for various application flooding in PSA for Doel 4 and Thiange 3 units. Prior to SunSource, he was a deputy manager at Tractable Engineering India, focusing on technical due diligence, which is the leader in engineering jobs for solar and hydro projects across Asia and Africa, and worked as technical consultant for smart city project in India. Prior to joining Ampere Tech, he was associated with SunSource Energy as a manager design and major responsibilities including preparation of technical specification, contract documents, etc. So I, on behalf of the FDP committee, welcome Mr. Tanmoy Ghorai as a speaker for the first session of second day of FDP. Please, sir, it is up to you.
Yep. Thank you, Mr. Shubhankar De. Thanks for welcoming me on this FDP seminar. Am I audible?
Yes, sir, you are clearly audible.
Okay, fine, perfect.
Okay,
great. So yeah, good morning, everyone. I hope you guys are safe and sound during these days, in this COVID pandemic situations. I hope you and your family, friends, everyone is safe. So, just a minute.
কবে ডেট ছিল, কবে নিয়ে ছটা করতে হবে, আগে খাস করে 3টে হয়েছে। তুই সব তো বললি দুর্গাবাবু, বাকি বাকি আছে পড়ানো। ইলেকট্রিক্যাল ভেহিকেলটা দেওয়া আছে 3টে, দুটো হলে 10টা কমপ্লিট, 10টা মধ্যে 6টা।
My screen is visible.
ক্যাম্পাসে যে কথা শুনছি, যারা কোনদিন আসে না এবার তারা আসা শুরু করেছে, মানে অ্যাডমিশনে ছিল ক্যাম্পাসে।
Is it visible, my screen?
You can start.
Yeah, okay, fine. Yeah, so basically, as Shubhankar mentioned, that by profession I'm a civil engineer, and having an industry experience around 9+ years experience across various renewable energy resources across Asia, Europe, and Africa. So basically, I involved majorly with the technical part in terms of the civil aspects, different civil aspects, and also some kind of a techno-commercial and some kind of a business development support, for last 3 to 4 years. Yeah, it is honor for me to give us some kind of an overview of the different yeah. So, just an overview of the total like renewable energy industry domain, like in India, and what's the current market going, current market trend, what is the potential, and like few technologies, in the solar power, like which is currently like the government of India is working on, and there are a lot of different projects. So that's, I mean, that I will cover mostly. So, like for the kind of let's say in overall industry market, so in India right now, in the renewable energy resources, the government of India is focusing majorly of the solar, wind, and your hydropower, small scale hydropower, and also hydrogen project. So because there are a lot of things why the government has spending much more time and money for these renewable resources. So in India, we have a huge potential of the growth of the like industry. So in terms of the manufacturing, in terms of the pharmaceutical, in terms of the like capital goods. So there are a lot of demands. So because of the like industry, like the upcoming industry, so there are a lot of huge demands of power. As we all know that India has a majorly for the last 3 to 4 decades majorly depends on the thermal resources, coal. But like what we have seen that the climate change, because of this like coal burning, the carbon emission that will affect to our environment, as well as you know that like the ice melting, like kind of the temperature increase like around 2 degree. So that's the major like aspect that the whole world is concerned right now, and that's why they are looking for the alternate solution of the conventional source. So what is the other way we can look at that? So instead of coal, what the other sources in the natural we can use that, I mean, the harness the potential of the energy. So out of that, the solar power is one of the most, I mean, the biggest like harnessing about the power, because it is abundant on earth. So and India is strategically, the location is such a way the solar radiation like in whole continent in terms of the let's say the like mid part of the like India. So the solar radiation is quietly high, and out of that, so we can generate the solar power through the, I mean, the electricity, and that can be that can match our requirement at certain point of like time. So for that particular purpose, the government of India has ambitious target. So they have a target around 227 gigawatt of the renewable energy capacity by 2022 and 275 gigawatt by 2027. Out of that, like around 67 gigawatt of the wind power, 31 gigawatt of floating solar, and 114 gigawatt of the solar capacity they want to achieve. And for that, they have a lot of different policies, different schemes, and different government subsidies they are giving right now. So the next part is the increasing investment, because whole world is currently looking after India as one of the like big opportunity market. Why? Because in India, the crowd is quite like mid-range, like 25 to 35 years of age, kind of young people age, and the industry revolution is coming because of the internet on things, machine learning, artificial intelligence. There are a lot of things like in industry aspects it's going on. So all the foreign investors majorly, so they are looking into India to put their investment in a long-term scale. And for that particular point of view, India will be benefited from this particular their target about the renewable energy sources. So that's the point. Like first one is the like why it's India, why the investment is coming, because of the robust demand. One is first is the robust demand. Second is the competitive advantage, increasing investment, and policy support. So robust demand, as I already said, there will be huge amount of like power needed from different industry, the householding uses. So we need to have certain source of energy so that it can the demand can be like matched. And what is the competitive advantage? Because the solar radiation, as I told, that in India strategically location in such a way, so the solar radiation is quite high, and we can generate more power during the daytime, like let's say from 8 to 8:30 morning to let's say 4:30 or 5 in the evening, like in the summer season. So and we can take maximum like get out of that. The third part is the investment. Like all the US, all the foreign investors, they are like putting huge amount of money. Like around last like 1 or 2 decades, they are putting around like 20 to 25 billion dollar. They have an investment. So and also the government policy support. Without the government policy support, no projects can be viable. So for the current project, for the current government, for the last 8 9 years, they are doing tremendously well for the like to promote the renewable energy resources. So there are like from the like what are the forms of the renewable energy resources? So one is the major part is the hydropower. This is the like large scale hydropower, and another is the other forms of the renewable energy that comprises of small hydropower, that is around, let's say, less than 25 megawatt, wind power and biomass power, and the solar power. In the biomass power and the urban and industrial waste power, these are the major kind of a renewable energy resources at present currently in India. They are looking on. So in terms of the like, if you see the generation capacity, so if you see here, kind of like the, let's say from the year 2016 to 2021, if you see, it's a kind of a substantial growth, like from 45.9 gigawatt in the year 16, and now it's a 90.4. So if you see the annual growth rate, the compound annual growth rate, it's around 17.33%. So now you can imagine, like within every 6 years it will be double. Like from 16 to 2021, like 6 years, the capacity has been doubled. And out of that breakup, so the wind and solar power is the most dominant, let's say, renewable energy power that is produced. So in this aspect, so also in wind power, because the wind power you can't put everywhere in the wind power. So majorly it will follow the coastline, like let's say in the west coast, majorly in the west coast, like you're from Mumbai like to southern part of the Chennai. So it's the majorly the Bangalore, Karnataka. This particular region is the vast potential source of wind power. And for the solar power, majorly the most the dominant states are Rajasthan, your Madhya Pradesh, Gujarat, Maharashtra, your Tamil Nadu. So these are the 4 or 5 major states which you can see the most solar power plant has been established. So if you see the electricity generation, like when you see the consumption, the demand, when the demand will go, so the electricity consumptions will also substantially go. So whether it will be residential, whether it will be commercial, or whether it will be industrial. So in each and every aspect, the consumption of the electricity is getting higher and higher, like year on year, if you see. So you can imagine, like 5-6 years before, like the way you live your life, and right now, like after 5 years. So if you see the compared to the lifestyle, maybe it will not be huge change, but yes, if you see substantially, it will change. Maybe you are having a better life, you are having good like things what you want. So all the things, if you see in a broader aspect, you will see the generation capacity is increasing in tremendously. So if you see here also, in the numbers of year 2016, so it's around 65.78 billion units for the renewable energy resources, and for the year 20, it's around 127. It's almost like kind of a double the in the 5 years, the electricity generation. And it comes from like majorly from the solar power and wind power. And if you see here, so the government has the established, when India has a capacity like to increase the renewable energy capacity by 500 gigawatt by 2030, and government is working on that to achieve the goal. So by the kind of the state, if you see here, the major state contribution to the like solar installations is the Karnataka is the number one right now. So they are having like kind of a 7.3 gigawatt capacity they have already installed, and subsequently like Rajasthan 5.3 gigawatt, Tamil Nadu is 4.2 gigawatt, Telangana is 3.9 gigawatt. So it's a kind of a like say top 10 state the renewable energy resources. Like, so if you see here, all the things like Rajasthan, Tamil Nadu, all the states are having major solar radiation. I mean, kind of a let's say like total capacity, whatever they are increasing in terms of the megawatt, it's a huge. So in terms of the hydropower also, like in last 10 years, there is not having like so much of hydropower like addition in terms of the renewable energy capacity, because there are a lot of environmental constraints are there. So when you do the hydropower plant, like let's say in the like mountain, like let's say Uttarakhand, like Himachal Pradesh or Arunachal Pradesh, Sikkim. So there is a lot of concept of the land acquisition. So land acquisition is one of the biggest problem in the hydropower. And also because when you put the hydropower plant, so there will be a lot of the environmental impact, like you have to cut the trees, and there will be a lot of deforestations. You have to remove the urban locality to some other place, and there are a lot of political issues are there. So in terms of the hydropower capacity addition, it's not that much of significant as compared to solar power, wind power, and also kind of a hybrid system. So if you see here, like in October 2020, some particular company, they have announced an order of kind of a, let's say 2000 megawatt in the hydroelectricity in Arunachal Pradesh, but it's still under discussion. It's still undergoing. It's not kind of, let's say, finalized, or the detailed project report has been prepared. So there are a lot of projects in the pipeline, but due to environmental constraint, political issues, the hydropower capacity is not having that much of significant. So for that, like to promote the renewable energy resources as much as possible, the government has like they have some kind of strategy, they have adaptation to promote the renewable energy resources. So one is the kind of a full integration. What is full integration? That means like there are, if you see, I mean, in last 6 months or 8 months, newspaper government has promoting that PLI scheme, that productive linked incentive scheme. That means, let's say if you are building a plant, like let's say solar plant. So you need the solar panel, you need the inverter, you need the cabling, you need the transformer, you need the substation part. So what government has asked us, like asked the companies to do, so if they can manufacture the products themselves in a certain scale, so that what will happen, so that they can utilize the domestic products. So they don't have to buy or they don't have to import from, like let's say China or from the other Southeast Asian countries. So that for that particular reason, government has imposed the duty, the different basic duties, custom duties are there. They put on the import of the solar panels and the inverters. So when they put that much of extra duty onto the particular product, then the project cost is really getting higher. And at certain point of time, it is not also feasible, financially feasible. Project is maybe feasible, but the financially it may not be feasible. But why? Because of the tariff. So if you see, is number 3, the PPA. PPA means the power purchase agreement and the lower tariffs. So now if you see right now, the solar power, that is the minimum rate, is currently the bidding price is around 2 rupees per unit. Now you can imagine you are paying the electricity unit as per your home, let's say around the domestic consumption, it's around 4 to 6 rupees. If you see, like when you pay your electricity bill, but if you see the solar power, the tariff is around 2 rupees per unit. So now you can imagine, and you are paying for the 4 to 6 rupees because of the coal. Maximum is the coal thermal power and the hydropower. But when you adapt the let's say solar, wind, hybrid system, your tariff is getting lower, because there are a lot of to build a power plant, there are a lot of different various aspects are there: time, project cost, the land, the environmental impact, lots of are there. So because of these renewable energy resources like solar and wind, when you utilize, there will be minimal less like environmental impact. They're very significant amount. And there is also called the strategy they have adapted, the decentralized solar power, kind of a off-grid solar. Like when, let's say, if you are building a plant let's say in Assam or maybe in the mountain region, you will not be able to find somewhere the electricity grid. I mean, it's not possible that everywhere you will get the electricity grid by our Power Grid Corporation of India or different electricity the company. So in particular case, you can use the off-grid solar. So let's say if you have a 20, 40, let's say small houses and small village, you can put a off-grid solar power and you can take advantage of the of that. And government has subsidized that particular scheme also. And also the last part, the shift towards the non-conventional energy. The government has clearly indicated to the commercial and industrial sector that they have to purchase at certain part of or certain percentage of the electricity from the renewable energy source. That is called RPO, renewable power purchase obligation. That means if you are consuming 100 units of electricity in a day, you have to consume 15 to 20 units from the renewable energy source, and the another 80 source you can take it from the conventional source. So that's what the government is like promoting or forced to do like for the commercial and industrial sector, so that people will aware of the great benefits of from the renewable energy sources. What are the growth drivers? Like mainly the government commitments and the government initiatives, favorable policies, and the investment. Because see, India is like at present is the fifth richest country in the world. Although we are the fifth richest country, but as compared to let's say like USA or China, we are quite far. If you see the GDP, the gross domestic product, it's around like $5 trillion right now in India. And as part of the, if you see the in US or China, it's more than $20 trillion. So now you can see the gap between the first, second from the fifth. So India needs really big amount of investment to promote or to fight the climate change for this aspect. So all the like big investment like from the foreign direct investment, it's coming like last like 4 to 6 years. It's a huge amount, and they are promoting this particular fact that India needs to change from the power consumption from conventional to the non-conventional source of energy. So there are different government policies that are like wind power, as I say, that repowering policy to change like to suitable for the users, like the policy, the wind solar hybrid policy. As I said, that the renewable purchase obligation, that you need certain percentage of the electricity you need from the solar power or wind power, that is the mandatory, and you will get benefited out of that, like the tax benefits. Also the government schemes, and there are different energy modeling in India Energy Modeling Forum. There is the organization called the Niti Aayog. They are taking care of all the things, right? All kind of like investment, the conference, the promoting to the solar to the different states. And the last one is the scheme for development of solar parks and ultra mega solar power projects. So what is solar parks and ultra mega solar projects? So normally if we see normally the solar power plants, it's around 25 to 100 megawatt scale project in one particular location. But when we say the solar parks, so it will have around, let's say, more than 400 500 megawatt. So that means it's a huge like in one particular place you will get 400 500 megawatt. So just for your information, to build 1 megawatt solar power plant, you need 3.5 to 4 acre. So right now as per the new technology, it will have around 3 to 3.5 acre the land. So that means if you have to build a plant 500 megawatt, so it will have around 1,500 acre of land. So now you can imagine it's a huge. So it's a huge power project. And for that, government has like, let's say, they are building new transmission line. I mean the high voltage transmission line for this kind of solar power plant evacuation. You need to stabilize the grid and to stabilize the electricity for the longer term. So they are building a like I think around 720 kV line. I think power grid they are building for that. So in terms of your investment, if you see the new investment, they are kind of a because of this pandemic situation from the year of 2021, the investment is a little bit slow, getting lesser, but in the longer run, India will have a huge kind of let's say the investment, the foreign direct investment. So if you see here, like the in June 2020, the Adani Green, they have a tender to set up a 8 gigawatt of manufacturing linked solar scheme, around 45,000 crore. So they already own. That means they will produce the solar panels in India itself. They will not import like from the other country. So it's around 8 gigawatt. So this is one kind of major investment that the Adani groups are currently they are ongoing. Also the same thing, the UK energy major, the British Petroleum BP, they have also kind of a $70 million investment in the upcoming the large scale projects for the commercial and industrial projects. Tata Power, they have a different like 100 megawatt solar project in Dholar Park that is already, I think it's currently almost finalizing of the stage, the 100 megawatt solar project. So these are the like kind of a major investment that you can see like for the last 2 to 3 years. Although in this pandemic, there are a lot of like the projects is getting slower because of the manpower is not available. Also the equipments which is needed, that is also not possible to import from other country because of the shortage of the container, and the price is getting higher. So the project is somehow, a lot of projects are under like currently stagnant because of the price hike of the module and the transport logistics cost. So if you see, there are major like 7-8 major development investment, like the one is the Asian Development Bank, one is AIRO, Singapore Private Limited, Areva, Ostro. They are the major like the investment like they are doing currently in India. So it's a quite good number, and they are putting a lot of amount of money in the specifically in the commercial and industrial sector. So for the potential, the growth potential, India has a huge kind of, let's say, potential of the solar power. If you see the total estimated capacity, it's around for the solar power itself, it's around 750 gigawatt. So if we can achieve out of 1/7, like that means around 100 gigawatt, because India has a consumption of total of 150 gigawatt right now. In India, we have a consumption 150 gigawatt. So out of that, if you see here, from the solar power contribution at the energy potential, so it's around 750. But in the realistic point of view, so India, the government of India is targeting around 100 gigawatt by the year of 2030. So there are kind of, let's say, new technology adaptation, like how the different technology they are adapting. So it's a kind of a snapshot that the project which I am working on, it's an outside, it's in Netherlands, but the concept is the same. Whether it will be Netherlands or India, the concept will be the same. So it's a kind of it's an overview of the solar power plant. If you see here, this is the kind of your solar modules that is kind of packed up in the orientation. It is in such a way so that it can generate maximum the electricity units. So if you see here, so normally the solar power plant, when you design the plant in such a way, you have to see the cost, the time, and the fast how you can the construct. So this is called conventional ground mount solar structure. So this is your kind of the two-legged structure with the purlin raptor. The module is being fixed, and the module is being connected with the series, and the DC cable is connected through your inverter station. After the converter, the AC converter, then inverter to the transformer and to the power grid. So there are for the solar power, apart from the conventional solar power, there are a lot of different new technology like agrovoltaics. It's currently it's a huge currently the government is focusing on. So how it looks like? So you see here. So there are different types of agrovoltaic structure. What we will do in the foreign countries? So what they do? So they raise the structure, they raise the solar structure in a such a height so that they can cultivate or they can agriculture. I mean they can have some kind of a like fruits, vegetables underneath. They can produce, and it has been seen that like when you expose to the sunlight, the production of the different crops has a better effect when you put the solar panel onto that, like kind of a shading. So what you can do, so in the same field you can generate the solar power, as well as you can product your the crop, different crops like grapes, like your cabbage, like a lot of different vegetables are there. So this is kind of a huge untapped potential, and the government is currently focusing on different projects also. So if you see here, in the major projects, it's in the Germany, Australia, France, and kind of around 1-2 megawatt scale to 25 megawatt scale. So and in India, it's they have currently in Mumbai and in Tamil Nadu, there are pilot projects going on for 1 megawatt scale projects. So it's a kind of there are different technology, kind of a like fixed tilt. That means when you fix the module in a such a orientation, it will be fixed for the 25 years. So you will not change the orientation of the module. So it will get the maximum radiation for the whole life of the plant. But here in the left side, you can see it's called the single axis tracker system, east to west. That means it can track the sun path. So from the morning, when the sun rises from the east, so it will move to the like automatically to the east, and when it is sunset time, it will go to the west. So it can take the maximum solar radiation, and the energy generation is quite a high number in that but the capital cost is quite high. So if you see here, so this is kind of called the conventional solar, like different lands you are using for the solar and for the vegetables. But here in the right side, you can see in the underneath you are kind of like, let's say, producing the vegetables, and above that you are having kind of a solar plant. So this is called the agrovoltaic system, and this is called the there is another technology. It's called the floating solar. Floating solar, we have lot of like hydropower plant already inbuilt, and also different the lakes which is quite exposed. So what we can, the new technology has done that. So you can put the solar panel like onto the big lake or the reservoir, different the big water reservoir in projects. So for that, different like technologies we need to adapt. So this is called the floating structure. If you see here, so this is the area. This is called pontoons. So you can fix the solar module in this particular part, and there is a called the secondary floater. So this is the floater system. So you have to fix the module here, like all the like clamping systems are there. It can like sustain all the waves, like, and also like the wind. So the system will design in such a way it will not sink. And this is the floating system, the floaters where you have to the maintenance purpose. So you can use during the cable laying, if you need to do the like cleaning of the modules, if you need to let's say go through like one inverter to the another inverter stations. So you can use these particular floaters. So if you see here also, so this is the kind of a like metal structure. So this is kind of a like the old one, so they have used, but nowadays they are using this is the high density polyethylene, HDPE member. So this is the floaters, this made up of a high density polyethylene, and also the fiber reinforced plastic or medium density polyethylene. But because of the cost and also the viability of the project, currently the HDPE members, the HDPE the material is being used for the floating solar power plant. So how you will fix the floating solar power plant when you put the let's say the solar panel above the above the water. So this is called the mooring system, anchorage or mooring system. What it will do, how it works? Like let's say when the water level rise up, so the system is designed in such a way, it's a kind of a spring system. If you see here, so when it will get tension, let's say when the water level rise up, and when let's say when the water level goes down, so the contraction will come. So it's a kind of a tension and compression. So these are the mooring system that will work as per the water level changing. So and how you will fix the module from the on the the shore of the the river or the ground, that called, it's a kind of a bank anchoring, or kind of a let's say that only the bank anchoring system that is being used currently to fix the solar module in that particular place. So inverter and equipment also, when you put the solar power plant onto the large lake or the reservoir, you have to do the different cables. If you see here that all the cables, all the small inverters. So right now 8 years before, normally the inverter is a central inverter and has been used. But nowadays, because of the small chunk of the solar power plant has been used and the efficiency of the solar power plant can be increased, nowadays the string inverter has been used, and it's a quite a size. In size, it's quite a small size, and it's very useful for the the big solar power plant. Because let's say if any particular reason your solar power plant is not working, so then in a particular portion whole power plant is stopped. But in a string inverter, what we will do, in a certain portion it will stop, but the other part of the plant it will work as it is. So you see here, so these are the floaters, and all the inverters are placed up, so that you can check for the maintenance purpose, and also for the cable laying it's quite useful. And also the plant life is also for 20 to 25 years. So if you see here, that is kind of a overall let's say kind of a the brief overview. So if you see here, the solar panels, the person is cleaning. This is the floaters, and this is the mooring system. The anchorage. If you see here, the ballast structure they have been put up because of the to intact the solar module, and this is the anchorage, the bank. If you see here, and all the cables are going onto the floaters to the grid substation. So in the floating solar, what is the good advantage is that there is no land requirement. So you have to just put the solar power plant with the floaters onto the water. So that's all, and you have to just do the cabling, sizing the inverter, and that's all. And also, what is the good thing is that in the floating solar, like when you normally put the solar power plant on the ground, the solar power plant gets hit. I mean, it's heated. Like during the summer season, the temperature is going around 40-45 degree. So the panel efficiency is when the increase in temperature at certain point of time, the module efficiency will be lower. But in this aspect, what will happen, because of the water evapotranspiration or evaporation, the module is getting cooler. So the module efficiency in terms of the ground mount, it's getting higher. But yes, there are certain aspects also we have to look in, like proper cleaning, and also let's say there are a lot of disasters. Like let's say if you have a huge flood, like let's say if you are building a floating solar in the Himachal Pradesh or Uttarakhand. So you have seen that last, I think 1 or 1.5 years before, there will be a huge flood. One of the big dam has been totally demolished. So in this aspect, so your total power plant will be totally kind of a I mean, it will damage. So you will not get anything on that. So those are the things we need to take care of while putting the projects. Because see, all the projects are involved the money. So all the investments, it's a huge amount of investment. For 1 megawatt solar power plant in the ground mount, it will cost around 3.8 crore for 1 megawatt solar power plant. So in terms of that is in the large scale project. But when you see in the let's say the residential projects, like let's say the school, college, hospitals, building, so people are using on the rooftop solar power plant. and that's quite a good number. And there are a lot of subsidy schemes are available. The people can get benefited out of that, because in the daytime from morning, like let's say 8:30 to 9 to 5, I mean, let's say you will have a really good amount of the electricity you can generate from your rooftop, so that you can minimize your electricity bill. So there are the other part is the like let's say called the hydrogen. That is the current buzz is going on like all across the world. That on the hydrogen you can put you can use, I mean, you can generate electricity. You can use in the transport, you can use in the heating like industry and buildings. So there are a lot of advantages. The green hydrogen production. So green hydrogen, the basic unit is the water. In the electrolysis process, they generate the hydrogen, and that is the hydrogen can be transported by shipping, by road, or by pipeline, and that the end user that can be used as a industry like steel industry, fertilizer industry, and refinery industry. They are being used in the hydrogen. There are a lot of cases. Also in the transport, at present currently the different let's say the vehicle units, like kind of a cars, let's say your train, your buses, your rails, already in outside of India, in Netherlands, in UK, in Germany, they are already currently using the hydrogen to use their vehicle, the daily vehicle, the things. Also, apart from the hydrogen, the electric vehicle also quite a good number. If you see right now in the current scenario, almost 8.6 lakh, around 9 lakhs units electricity car has been sold. I mean in the four-wheeler in terms of, and also there are two-wheelers also there. Also the same thing, the hydrogen can be used for the heating purpose, because like in the cold countries, they have a like kind of a temperature, it goes like -10, -15, -20 degree. In that aspect, they have to use at certain point of time to heat the room where they are staying, and for that they use before the different generator, diesel generator, other things. But right now they are converting to the hydrogen. So the green hydrogen application is quite a huge number. Like if you see here, the steel and chemical industry as a feedstock, in the heat process plant as a heating fuel, in the transport unit as a fuel for vehicles, like we use as a petrol and diesel. The same thing, the hydrogen can be used for the vehicle, like in the transport, like rail, your car, in terms of the power. So like from the natural gas to the hydrogen, and also the heating of the building units. So in terms of the overall aspect, apart from the solar power and wind power, government is also initiating like to look for the different the new technology like the hydrogen, also the battery energy storage. That is also a huge kind of a, let's say, potential of the storage of the solar power. Let's say you have a solar power plant from like solar power can generate from 8 to 4 p.m. But after that, you don't have sun, so you will not be able to produce the solar power or the electricity. So in that aspect, what you will do, so the maximum the utilization of the solar power, you can store that electricity or the power into the battery storage, and you can later on, like when in the evening time, let's say the peak time 6 to 8 p.m. or 9 p.m., so you can use that particular battery storage energy to the normal daily life. So that is, government is also quite promoting to let's say the battery energy storage system. But what is the major challenge there? Battery energy storage system, the cost of the kind of the cell, because in India we don't have that much of the production of the cell, so we have to rely on the import of the cell from the China or from the Thailand or from the other countries. So when you import those materials, that the cost is getting higher. So that is one of the major challenge currently that we are facing. But I guess when the major deployment of the battery storage will come, I think the price will go down. And in that case, in that aspect, the battery energy storage system is quite also viable. So these are the major, let's say, new technology. Like as I said, one kind of like agrovoltaic, like in the ground you will have your vegetables, and above that you will have the solar power. Second is the floating solar, that when you have the land constraint, when you don't have the so much of land you will be able to get to generate the solar power, you can use the use the abundant water, I mean the lake or the empty reservoir that you can use the by using the solar power you can generate the electricity. Also, like the hydrogen, at present the market is currently looking after. It's a very initial stage, hydrogen. There are a lot of like research and development. It's ongoing, and we are currently looking after like certain pilot projects in Rajasthan for 1 megawatt or 2 megawatt scale project. For the hydrogen, one good thing is that apart from the electricity unit, you can generate ammonia, and ammonia can be used in a lot of different chemical industry because of the hydrogen and the nitrogen they are blending, and so you can get the ammonia product, and that can be used for different purposes for the chemical industry. So that is also quite a good thing. And the byproduct is the water. So when you use the hydrogen in a vehicle or like the other industry, the byproduct is the water, because H2 and the oxygen, the atmospheric oxygen, it will get the normal the water that will not harmful for the for the environment. So the major idea is to that whatever we use, it will not have that much of impact in the environment to register climate change, to reduce the carbon emission. So that is the major goal, and all the research and development team and all the government officials, they are working on that to promote as much as possible. And I think in the longer run, we will have a really sustainable life, like let's say after 8 or 10 years. Because when you see the contribution of the renewable energy sources before 8 to 10 years, and now you will see the huge change. And also there is in the same prospect, the coal thermal power plant, the contribution of the thermal power plant to the electricity, generation, it's getting lower and lower. It's not about only the India, it's about the whole world. They are they have placed that they will reduce the conventional, that is the coal source, like year on year. And I hope in the upcoming year we will have a really bright and a good future for the environment, and we can sustain that. So thank you so much. Thank you for listening, and if you have any questions, so I will be happy to kind of discuss.
Thank you, sir, for your valuable information regarding renewable energy aspect on India and various subcontinents. You have also focused the future era of renewable energy. Now, I would like to request the participants, if you have any query or questions, you can write in the chat box, or you can directly unmute your mic and ask Mr. Tanmay Gorai, sir.
Yeah, I mean, feel free to ask if you have any question, kind of a, let's say, technology, or let's say in the design. So, like you can aspect from the civil design aspect. I can clarify because I'm not the electrical guy. So I will be happy to discuss with them. Yeah, sure.
Sir, I just wanted to ask you, when you were speaking about hydropower plants or hydropower, that thing, then you said that land acquisition are a bigger problem for that. Can you just explain in detail, sir?
Yeah, sure. So see, when you build, I mean, land acquisition, what I'm saying is about the large scale solar plant, not for the small scale solar plant, right? Why? I'm telling you, for the large scale solar development, when you go for like 50 to 100 megawatt scale project, so when you put up a dam, so when you put up a dam, so that means you are obstructing like the water, like in a certain aspect, so that it will the reservoir area is quite high, because of the huge amount of water to store the water, right? So in that aspect, so you will have a lot of deforestations. The state government or the local people, they will not allow to have an impact on the like the land, and also the surrounding climate. It's also getting changed of the deforestation. And also when you store that much of huge amount of water, sometimes what happen, like the village or the community which is being there already, you have to remove them from that particular place to the other place. So if you can imagine, if a person is living for, let's say, 30-40 years of his life, and you suddenly you say, Joe, you have to move on to other place. they will oppose the things. And also there are a lot of political issues are there also. So all the things like land acquisition and also the political aspects, it is really creating a problem for the development of the hydropower plant.
Thank you, sir.
Okay, thank you, sir. The government are taking initiative on several areas for subsidy and other projects like Niti Aayog, etc.
Yes,
for improvement of the renewable energy sources. So we hope that government will help the common people for this for acquiring the renewable energy sources.
Yep.
Once again, thank you, sir. Any more questions from the participants?
No question.
Okay, sir. Once again, thank you for your kind appreciation, kind knowledge sharing.
Yeah, always. I really thank you to everyone to having me having a small conversation. And if you have any question, feel free to ask me at any point of time. I'll be happy to discuss with that. No problem.
Okay, sir. Thank you.
Okay, thank you, everyone.
Our next session will start soon. Please be with us. We'll start the next session within 5 minutes. The feedback link is available in the chat box for the day 2 session 1. You can fill the feedback link. And one more thing, feedback link filling is mandatory to get the certificates. Without feedback filling, we won't provide you the certificate for the 3-day FTP. So please fill up the feedback link for the day 2 session 1.
Very good morning.
Good morning, sir.
Good morning. Am I audible?
Yes, sir, you are audible. 1 minute, sir. For the participants, please fill up the feedback link quickly. We are going to start the next session. Our eminent speaker has already joined. Okay, we are going to start the day 2 session 2. We have with us Dr. Hashim Ali Khan, who have completed his Masters in Technology in Structural Engineering from NIT Durgapur and have his PhD from Civil Engineering, Structural Engineering from NIT Durgapur. He has several journals and conference papers and also book chapters. He have relevant experience in different colleges like Bishnupur Public Institute of Engineering as a lecturer and also as a research scholar from National Institute of Technology Durgapur. He is currently associated with G.H. Raisoni College of Engineering Nagpur as an assistant professor from 1/7/2021. He has been awarded with the Best Paper Award from Punjab University, and also he has an awardee from Human Resource Development, Government of India. He is associated with professional societies like American Society of Civil Engineers, the Masonry Society, Indian Society of Earthquake Technology, and American Concrete Institute. He is also a reviewer of various journals, conferences like Bulletin of Earthquake Engineering, Advances in Structural Engineering, Environmental Geotechnics, Journal of Fiber Science and Technology, and Materials Today. So we are very happy to have with us have Mr. Hashim Ali Khan with us. He will share some experience and knowledge regarding renewable energy resources. So over to you, sir. You can start.
Yes, very thank you for nice clarifications and introductions. Thank you, sirs. I am first thankful our chief patron, Dr. Lakshman Seth, sirs, patrons, Dr. Mr. Ashish Lahiri, sirs, Ms. Special Pandey, sirs, and conveners, co-conveners. I am also very thankful. I am the alumni of the Heritage Haldia Institute of Technology, BTech, from 2013 pass out. So I share my PPT and then I start my lessons. Yeah. Yeah, skin is visible. Yeah, skin is visible.
Yes, sir.
Achha, okay. Okay. Yeah, just 1 minute. Yeah, full skin is there.
Yes, sir.
Yes. Okay, thank you.
Visible, sir.
Yeah, shall I start the sessions?
Yes, sir.
Okay, fine. Yeah. So today lecture topic is the energy and seismic renovation strategies for sustainable cities. Actually, the planning of the energy saving and structural retrofit interventions on the masonry structures, like the masonry structures or unenforced masonry structures. There are two separate projects, okay, but their combinations, interventions are rare, very rare. So my main objective is the energy and seismic renovation combined strategies for the earthquake protection buildings like that sustainable cities.
Sorry, sir. 1 minute. Please press F5 for the full screen.
Okay. Yeah. Screen is visible?
No, sir. The screen is visible, but the slide is not happening for the full screen. You please go to the view mode,
View mode, no? Reading view.
or you can slideshow.
Yeah. So whole screen is visible?
No, sir.
Okay, just I stops here and begins here. Just wait. Entire screen. Save. Yeah, right now it is okay.
Okay, sir. Yes, sir. It is fully okay. Thank
Yeah.
you, sir.
Yeah, thank you. Thank you very much. Yeah, so my title is Energy and Seismic Renovation Strategies for the Sustainable Cities. Okay, so what is the happening for the energy renovation and for the seismic renovation? So there are two separate projects. Actually, what happened, the planning of the energy saving and for the seismic retrofit, that means seismic strengthening intervention on masonry building or any structural building are totally two separate innovations. Okay, but my objective is that combined interventions are very rare. My objective is that for both aspects, reduce total refurbishment cost and improve global building performance. However, heavy interventions on the envelope have to be careful design. So my objective is that for combined project is to be investigated for the structural building like the sustainable cities. Yeah, so these are the outlines. First one, introductions, and next is how your buildings behave during like that earthquake. And these are the literature review, the previous researchers done like that, and what is the problem. Right now, main objective is that problem. If you go for the problem, then it will be clearly observed, okay, there is the problem. So next we come for the solutions. Solutions with various retrofitting techniques, but today is the main focus is the for renewable energy sources with the effect of seismic interventions. And these are the workflow. Step by step, I will describe. Okay, first we have to know what is the retrofitting and repairing and how it comes, then how it will be reduces. So these terms which are associated for the retrofitting or strengthening technique, first one is the repairing. Okay, so what is the repairing process? It is a process of reconstructions and renewal of the existing building structures. Next is rehabilitations. What is rehabilitations? Actually, what is rehabilitation? Rehabilitation is that renewal of a damaged building to give same functional level which is prior to be damaged or not. Next is restorations. It suggests replicating the structure as originally it is built or not. Next is remolding. That means it is a process of substantial repair or alternation that extends a building's useful life. Next is retrofitting. Retrofitting is the process of the strengthening seismic efficient buildings in order to make them more earthquake resistant. And last one is the strengthening. It may increase the seismic resistance of a building beyond its pre-earthquake state. So first, my objective is that what is seismic retrofitting effect in building? Next, there's the problem. What is the problem identification? Next, the solution outcome. And last one is the main, our FDP program is the what is the renewable energy sources and how it will be implemented for this seismic retrofitting of the building. So step by step, I will describe. First, we have to learn for the retrofitting process. Yeah. So actually what happened for the masonry structures, actually main objective is that for various technique, I have to focus for masonry, how it will be renewable energy source, it will be retrofitted. Okay. So what is the masonry structure? Actually, if we learn for the masonry structure, there are two components. Okay. First one is the brick and next is the mortar. So mortar is the weakest part. So the crack propagation or crack will be started from the mortar to the brick, from brick to mortar, and like that header joint to bed joint to head joint. Okay, so that's why the masonry is called for the unreinforced masonry. Here, the unreinforced masonry is one of the oldest and most diverse materials which are used in the construction process. So that's why many number of the structures have not been designed for the proper seismic loads. That's why unreinforced masonry actually are vulnerable to collapse during an earthquake process. So there are two failure mechanisms for the earthquake resistant structures. First one is the in-plane failure mechanisms and next one is the out-of-plane failure mechanisms. So first we have to learn how in-plane behavior is there and then how it will be prevented with the renewable energy sources technique. and next is how the outer plane behavior is there, and next is the how it will be overcome with renewable energy sources. So there are our objectives. Okay, so one by one I have to describe. First, we have to know how do your buildings behave during an earthquake. Okay, if you see, there's the small basic components of the masonry building. Each the roof portion is there, next is the foundation portion is there, and next is the small 4 walls. That means simply 4 walls is there and door or window is there. Okay, so what happened for the during an earthquake? During an earthquake, the floor slab moves rigidly in a horizontal direction. That's why both the shear crack and the moment, it will be incorporated in the building. That's why one diagonal, one wall, it will be rectangular wall. That means if we go for the figure number B, the one rectangular wall, it will be goes for this parallelogram shape. So that's why the crack initiated for the diagonal portions. That's why it will be caused for the in-plane shear. That means one diagonal cause extended, another diagonal cause reduces, contracted. Next, it will be another wall, it will go for the toppling. So that's why the outer plane failure mechanism is there. If we go for the B, this part, so that's building, it will be removed for the A and B. Wall A is to be in-plane failure mechanisms and wall B is to be outer plane failure mechanism. So that's your building behave during an earthquake. First, we have to know how the earthquake, when earthquake comes, the building, what is the behavior and what is the causes of the retrofitting. Okay, so the seismic strengthening technique is the cause for the retrofitting process. So like that, various researchers do that various way. Okay, so in the way, that means if you see that figure, they are connecting for the lintel band. That band gives the more prevention of the building. But thing is that there is no renewable energy causes, because the thermal insulation, it will be there. And for the, if you go for the FRP technique, then the epoxy resin, it will be goes for the another thermal operations. So our objective is that how it will be prevented during earthquake with the help of the renewable energy sources technique. So next plan I have to describe for the during in-plane failure mechanism, how the walls are behave. Okay, there are 4 failure mechanisms under in-plane failure mechanism. First one is the shear failure. That means it will go for the bed to head to bed joint. Next is sliding failure. That means it will be sliding from the lower bottom to upper bottom. And next is rocking failure. That means when both moment and shear force are causes with the axially. So that's why it will cause for the rocking failure. And next is the toe crushing failure. Toe crushing failure, that means it will be happen from one corner to be rotated. That's why the toe crushing failure is there. So all are goes for the in-plane failure mechanisms. Next, if you go for the outer plane failure mechanisms, then the seismic forces, when it go for the in-plane, the another wall, it will go for the outer plane failure mechanisms. So these are the totally 2 failure mechanisms in the building. Okay, that's the in-plane failure mechanisms and outer plane failure mechanisms. Okay, so another examples for the historical review. If you go for the historical background, there are lots of examples are there. Okay, but I have to describe in the 1 or 2 examples, realistic examples. First is the pancake failure of the tobacco factory building, which is caused by 26 July 1963 in central part of the Skopje earthquake due to the Skopje earthquake, the Macadamia. Okay, next, another renovation strategy, that means reconnaissance of the effects of the magnitude M7.8 Gorkha Nepal earthquake. It is a devastating earthquake cause, and the building are devastating cause for the in-plane and outer plane mechanism. If you go for the figure number A, this is the outer plane failure mechanism. If you go for the figure number B, so that's building collapse started from the crack portions for that way. Okay, so these are the in-plane, outer plane, it is side by side both way, because the behave during like in-plane and outer plane. So that's a simultaneously occur in the building. So first we have to learn how the crack propagation is generated. Okay, so mainly it is cooperated for the diagonal portions, for the door portion of the roof portions. So whatever it will be their crack propagation, it will be there. So that's why during earthquake, there is a vastly affected for the building. Like that masonry building, it will be very affected because only mortar part is there, and mortar is the weakest part. But if you go for the reinforced concrete building structure, reinforced structure, RCC structure, so that will more prevented. But thing is that the beam and column, that means beam column junction, are in-plane plane, so crack initiated for the connection junction portion. Okay, so I will describe for the crack portion, next will be investigated. So what is the main objective for the masonry? Why? So if we go for this standard database, okay, so standard database we always recommended for this Scopus database, okay. So if we go for this Scopus database, so there are lots of researches done in the various ways, okay. But my intention, my objective, we go for the masonry. Because why? Because the masonry is the most popularity, okay. So if we go for the rural areas or urban areas, okay, so urban areas, so many buildings are caused for the masonry because they are not development. If you go for the Italy, so various architectural building in our India, like that Kolkata, okay, or various ways, various architectural building is there. So my need is that if we study for the masonry, then it will be implemented, our heritage structure, it will be more prevented. Because if our heritage structure is lost, it will be lost forever. So our objective is to that, for masonry to the heritage structure. So there are lots of researchers do that way from 1960 from 2020, okay. So if we go for the keywords, then it will be database is there, okay. So just I replicate for the database, okay. So that's why if we documents which is published from the 2001 to 2020 and from 1960 to 2000, okay. So if you go from the 2001 to 2020, so like that 470%, it will be vastly researchers do that for like that masonry, because of the heritage structures. All heritage structures are like that for the masonry. So people are doing for that of the research for like that masonry, okay. Yeah, so next is the literature survey. Okay, so before you going to any research or any topic or anyone say, okay, first we have to know what is the main cause. Okay, and next we are searching what is the previous researchers done, do like that. Okay, they are doing for the FRP sets for like that band. They are doing for the diagonal shear strength, for preventive diagonal shear strength. They are doing that twisted stainless steel reinforcement. Another researchers do that like that. They are using the external basalt fiber and carbon basalt fiber, both are combined. Another researchers do that, welded wire mesh researcher is doing that, okay. Next are the cause of glass fiber reinforced polymers, okay. So lots of researchers do like that various ways, okay. Our objective is that for the with the help of renewable energy, how it will be prevented. These are the my objective, main objective, okay. So my objective is that to give an overview of the various strengthening techniques worldwide and its suitability in the context of India, because we are living in India, okay. So through an effective and obviously low cost strategy, because we are always familiar, if our strategy with cost benefit ratio is totally low, that means low cost technology, then people generally accept, okay. Next, first one is the to assess the in-plane shear fear mechanisms for the unstrengthened and strengthened brick masonry wallets through the renewable energy resources. Number one. Number two is that to investigate the efficiency of the out-of-plane failure bending mechanisms through the renewable energy sources. And last one is the both combined effect, that means capacity interaction. It will be again goes for the renewable energy sources. And last one is the experimental results with the validation of the software result. There are lots of software is available like that FEM softwares, the finite softwares like that ANSYS, Abacus, ANSYS, Abacus, LS-DYNA software is there. Okay, so various researchers do that like that way. So we are also converting that way. Okay, so in the next is going for the testing. What is the need for testing? Because if you know for the testing how much it will be implemented or not. Okay, for the independent failure mechanisms, for diagonal compression tested is suggested for the code of American Society of Testing Materials E519. So here I have tested in our NIT Durgapur laboratory when I have completed my PhD work. Okay, so these are the reinforced buildings is theirs. Okay, so here the wall are totally loaded for that way for the according to the STM code, and like that various pattern I have used with the use of FRP thermal insulations. Okay, so like that diagonal pattern, parallel pattern, or combined pattern. Yeah, next is the 4-point bending test for the out-of-plane prevented nozzle. And again, it will go for the suggested for the American Society of Testing Materials for the E518 testing program. Okay, so what's the result outcome? I step by step define. Before I go to define, I have also analysis with the numerical modeling. Okay, so if you go for the numerical modeling, so final element modeling is the currently a popular tool because we know to evaluate the load bearing capacity, deformation capacities, and again for the various combination I have to predict it. Okay, so there are some 3 steps is there. Okay, number one is detailed micromodeling. Here, the brick, mortar, anyone, FRP concept, anyone, any material thermal insulations, you have to plot here, and separately it will be inputted. Then result will always come. Next is the simplified modeling. Here, we have to study for one conjugated here. Okay, and last one, the macro modeling. Here, macro modeling is the time consumption. Okay, so actually what happened, if we go for the numerical solutions, the lots of time is there. So that's why researchers do that. Prevention, protection of the time, they reduce the time, they go for the macro modeling. So there's a lots of examples is there. Okay, so first I have incorporated for the any existing method, then I have to compare it for the energy renewable resources. Okay, so in our NIT Durgapur laboratory, I have resulted for that way the influential mechanisms for the controlled specimens. Okay, and if we go for that way, so here loads is maximum is 26.60. Okay, and corresponding deformation is there. But whenever you go for the any strategy method like that way FRP or geosynthetic materials for the wrapping portions with the help of epoxy resin, then results are outcome different way. Okay, so these are the algorithm. Here we see that roll increase for 40.70. So it will be successfully validated here. So again, examples for the examples of the diagonal pattern. Next is the cross pattern. Okay, so these are the both way single side and the both side is complicated. Okay, so these are the results are various ways for one side for the over side compared to the control specimens. Okay, so the effective result are both for the it will be increased for parallel to diagonal, diagonal to cross pattern, as well as one side as well as both sides. First we have to integrate here. Okay, so the software validation, it will be there. For that software validations, if we go for the ANSYS platform is there, so like that way how much prediction is there, it will be energy, it will be there. Okay, and from the energy deviation capacity, so how much energy it will be reduced, and this renewable energy it will be incorporated. This software also inbuilt it. Okay, so ANSYS Workbench platform is there, ANSYS Mechanical Ability. This program is done for the ANSYS Workbench platform. And these are the numerical predictions value, and for the experimental validations I have computed in our laboratory. Okay, so these are the testing parameters for the equations where the diagonal shear strain it will be calculated, and the validations for the how much numerical validations and as for experimental validation. Okay, this is the deviation is there or not. So if you see for the program less than 10% deviation is there, so that's why it will be called for the validations. Okay, there are minimum to video validations. Okay. Next, we go for the incremental diagonal strain. So it will be strain for the over one side, for the both side as well as. Okay, so energy distribution capacity it will be vastly affected from the, if you go for the parallel pattern, then 128. If you go for the diagonal pattern, 155.04 kilonewton per meter is there. And if you go for the cross pattern, then it will be increased for 168.95. Same pattern it will be observed for the both side. Okay, so 69.55 to 372.41 kilonewton mm for energy dissipation capacity is to be incorporated here. Okay, so the ductility factor have been increased. Ductility how much increased? Main function is the cost analysis. This technology is the cost analysis or not. Okay, so here see for the uncontrolled specimens, if you go for the 100% efficiency, then it will be, if we go for the cross pattern, that means the best pattern, so to 13% the deficiency is there. So that means is the difference is high, that means it will be applicable. Researchers do that like way. Okay, same concept is do for the autoplane testing for the control specimens. Okay, and for the diagonal pattern, cross pattern for single side, another way for the both side. These are the both side specimens. Okay, again the comparative studies there. Here we see for the control specimen 2, it will be increased for the parallel to diagonal to cross pattern. For over unstudied pattern, like way for both studied pattern. And again for the software validation is there for ANSYS software, and then the numerical prediction it will be validated for the ANSYS softwares. Okay, so next we go for the flexure strain calculated with the help of ASTM code, and how much it will be deviations. Here deviation is maximum deviation is 6.98. That means 10% deviation is there. So software prediction is to be incorporated here. Okay, so energy again you go for the energy distribution capacity. So like the 29.94 for the control specimen 2, it will be increased 34.15 to 65.89 to 98.56. Like that way for the one student, and like that way for the both side student. If you go for the both side student, so it will be how much effective to 16.174. So vastly it will be affected. For the energy it will be distributed for the conservation. Like the ductility factor and cost analysis, it will be again to 10%, so that the people accepted like that way. Again, if you go for the combined study, that means in plane and outer plane for the like that of both way. So here the experimental results it will be there. Okay, so here the in plane for that portion and outer plane for that portion. So combined effect it will be there. Okay, so again software validation for the numerical calculation is there, and for the here the energy distribution capacity for the curve is presented for the capacity interaction, which is called for the capacity interactions. Okay, that means the critical outer plane maximum load it will be vice versa, where the point it will be located from, that's why it will be increased or not. Okay, so here the maximum effect is there again for the cross pattern for the both side. Okay, so that like that way for the in-plane shear and outer plane bending combine is there. And for the analytical predictions, if you go for the nonlinear regression analysis, here we have to convert it that the ratio is to be in-plane failure divided by in-plane capacity, outer plane failure by outer plane capacity is equal to 1. That means the sequentially it will be increased. Okay, so here the next part, that means in previous part I just told how the seismic, when the earthquake come, how the building behave like that seismic, retro-seismic way. And next is it will be incorporated for the failure mechanisms and how much energy will be distributed. Okay, so in this way I have to incorporate it here for this sustainable city. Where is the sustainable city? What is the definition of sustainable city? If you go for the sustainable city, there are lots of structure is there. Masonry also is there, for like that reinforced concrete structures is there. So all are all together for the sustainable city. Okay, so here sustainable city enhances the economic portion, social, culture, and the environmental conditions, which is well-being of the current and future generations. Okay, sustainable cities sometimes the ecological cities are settlement for the design to have tighter impact on the environmental aspects as far as possible. So this can be pre-existing cities that features management directed towards reducing the inputs energy, water, floods, energy, reducing the output heat consumption is there for the water. Okay, so here it will be incorporated. Okay, so a controlled populations for whom adequate meaning of employment is available or not. Okay, so adequate government setup which can meet the needs of the population structures, which is ensures civic responsibilities, community participations, a sense like that way of identify transparency and accuracy of the local planning. Okay, so these are the characteristics. First one is I will go for the plan for housing colonies. Okay, here plan for housing colonies we have to educate the infrastructure like that school building, park building, drainage system, and all are considered for the load bearing wall. Yeah, so if you go for the load bearing wall, so during earthquake the wall tends to be cracked like the diagonal way. So in that way we have to keep it in mind it will be seismic earth resistant or not. Okay, so that's why the efficient basic civil amenities for a responsibility comfortable existence, effective environmental infrastructures to address this issue. Okay, so these are the social figure is there which just go for the environmental conditions, that means it is easily available for eco-friendly or not. Okay, so next is sociology and next is economical conditions. Whatever you have gone for, go for the economic condition. If it is economical or not, that will be very efficient for that like that way. Okay, so next is another way for the empowerment of the women and encouraging their participation in the political, social and economical life of a city, which is adoption like that urban peoples. Also, if you go for the urban peoples, we have take into account for your initiatives. Okay, so lots of hands is there for lots of organization is there like that way. Next is an efficient healthcare system which would also address the issue of the nutrition system is there. Next is mechanisms in the form of a policy initiatives for industrial dispersals. Next is development of an ancient urban infrastructure. If you go to private structure like that way, private school, private building, they are also like that way for the load bearing walls. And most of the various way because for the people are living for the masonry building. So they are the sustainable cities. If you go for the sustainable for Butcher diagram, so these are the sustainability leader is there. Next is sustainability advances 1 to 10. This 10 to 20 I have to describe here. Next to mixed result for sustainability challenge is their sustainability danger not is connected. So the energy and climate change policy. That means 16 conditions is there 16th century, 21st century. So like that way, it will be development for the sustainable construction of the city policy. Okay. So here the two are variant way, which is more sustainable, which are less sustainable. Okay, for the city development, for the urban areas, they are go for the most sustainable because there are lots of advantages is there. But if you go for the urban peoples, there are less sustainability there. Okay, so what is the difference between more sustainable and less sustainable? First one is the compact, which is forms of residential development infrastructure. Clear? Here, the low density is spread out the residential development. Next is mixed land use for the homes, job, shopping complex in close proximity. Here, segregation of the land uses for the homes conditions, jobs condition, and shopping separated into uniform transit structures. Next is employment-based permeability of the education and the skill system is there. For that's why people are learned that way. Okay, when earthquake come, this prevention is occurred. Beyond earthquake, we have to achieve that way. But here, employment based primarily on environmental polluting for non-relevant resources system is there. Another example is if we go for the hilly areas for the territorial treatment of the sewage, use of natural means of the sewage treatment. Here, discharge of the sewage into the water consumption system. Next is the protection and use of natural hydraulic resources. Here, the hard surface preventing, that means infiltration, channeling for the natural water courses. Okay, so these are the examples of the sustainable development cities. Okay, for Waben Fries, which is Germany. Okay, one city is there for the Germany. This is Waben, Fries, Germany. Okay, so neighborhood 5,000 inhabitants and 600 jobs for 4 kilometers. To that way connected, that like way of the cities way. Okay, here the peoples are various way like that high-rise building. Okay, and this high-rise building are the vastly affected for the when during earthquake. So this sustainable model, it will be implemented here on the site of former French military base and is named as Sustainable for the 17th century French ministry, which built to the 40th in Fragwatic while the regions were under construction. Next, how can the sustainability can be achieved for the compact urban form, which is permit higher urban densities, where densities is very much affected, set urban growth boundaries, that means like that way growth management system, urban land consumption very often occurs, which is the high quality lands is there. Next is the minimized conversion of the natural lands to the urban cities. And next is the very important for the retrofitting and renovation of the older structures, because our heritage structures is the total old building, that means heritage structure. If our heritage structure is totally lost, that means damaged, our history is lost. So with that way, we go for the retrofitting and renovation of the older structures as well as newly building development. Okay, so that's why the concept for the green building, like that way, this is the hot topics. What is the green building and how it will be implemented? Yeah, I again describe, again go for the human scale. If you go for the gives priority base to the pedestrian walls, like that way walkability reduces dependence on the automobile systems and enhance the aesthetic appreciations of the urban life. Okay, next is the mixed uses condition, that means increases the efficiency of the human interaction in the space, transactional intensity is there, is facilitated or not. Okay, next is minimizes travel timings, that means if you go for the travel timing, that means good transportation system is there for sustainable cities, and where the raw materials on the construction site which will be taken for that way within that time. Okay, so here therefore reduces the waste time and non-renewable resources like that petroleum, how it will be implemented. Next is important that pollutant agent. Okay, so non-polluting forms of the transportation system is there, minimizes impacts of the urban or air quality and how it will be implemented. Next is stage walking systems, biking, republic transit. So these are lots of prevention of that open space or green space is there for the sustainable cities, all together for the sustainable cities. If we go for the sustainable construction, provide a systematic of urban parks which are connected the systems that people like that colony to space. Okay, and then extensive trees and the landscapes. Next is the green, the concrete juggling, that means Flora is one of the best examples of the sustainables. It is a green area, totally concept of the greenery concept the open concept. And the examples for the solar system. Here, sustainable cities, if you development for that a greeneries way. Okay, and here the solar energy, it will be converted like that way for the greeneries, and the people's life are very charming. And here the prevention technique is also incorporated here. So like that, people are always implemented here for the day by day upgraded system. So next is healthy environmental elements. That means healthy air, water system is there or not, land is totally covered or not, aggressively rehabilitation degraded landscapes, minimize automobile dependency, isolate polluting industries and demand substitution. Next is use an integrated approach to the waste management systems. We go for the waste management system. There are 3 terms is there for reduce, reuse and recycle. Yeah. So main there are the tremendous reuse. Okay. So that's why the renewable construction. Next is design waste disposal cities and take particular care with the toxic waste. Use a municipal environmental concept for the impact assessment systems is there for the newly developed cities or not. And last one is the environmental rehabilitations. What is the environmental rehabilitations? Is there actually contributes to the environmental quality and human health, enhances, that means biomass productivity. That means if you go for the greenhouse systems for the like that carbon dioxide gas, it will be remedious or not, because this carbon dioxide gas is the prevention for the earthquake resistance building also, because here the rod is there, steel rod is there if your damaged building is damaged. Okay, and few portion reinforcement is there if your carbon dioxide is generated for that biological system, then it will be affected for that of reinforcement, and then it will be caused various way. Okay, and like that during earthquake it will be totally closed. Okay, so that's prevention, it will be there. Next is reconstruct water courses that have been buried contaminated sites. If your building is to be constructed like that way, it will be not incorporated for the water treatment system, then water it will be dropped or water is to be leakage that way. Okay, and that's why your structure is to be damaged that like way. Okay, next is the clean up the city, because garbage minimization efficiency is to be there. If your city is not clean up, that means garbage system is there, then lots of environmental pollution gas is protected is there, and they are caused in your building damage. So that's why the technique is to be covered that way with the sustainable construction. Okay, here the sustainable architecture system, that system seeks to minimize the negative environmental impact of the building by efficiency and moderation in the use of the materials which are converted to the energy and development space, like that solar system. So sustainable architecture which uses a conscious approach to the energy and the ecological conservations in the design of the built environmental system. Okay, so here we example for sustainability method that the needs of the present system with compromising the ability of the future generations to build their own way. Okay, so if you go for the high-rise building, here the greenery system is there. That means like that of gardening system. Okay, here if we system is here for gardening system, there are lots of light, lots of conservation, lots of energy is to be prepared here. Then prevention energy is to be converted for like that way for the energy system. Okay, so sustainable design. Next is reduce the negative impact of the environment. Okay, so if your renewable energy sources is kept, so we reduce the negative impact with the help of the renewable energy sources. And like matter human health consciousness for the like the various disease, cancer disease, it will be prevented. Okay, thus improving the performance during a building's life cycle. Okay, so already I have discussed how the building behave during an earthquake, how the crack it will be occurred from like that way. So we are prevented, we are keep in mind like that way with the help of renewable energy resources, keep that way, and then it will be implemented in your building, thus improving the performance during a building's life way. Careful consideration is given to the water leakage system, energy distribution consumption system, building material system, solid waste system. One by one example is there. This is the high-rise building, okay, and the total building is the green building concept is there. So maximum energy, that means maximum solar energy is to be incorporated, that's the building. Okay, so here the total gas, that means carbon dioxide gas or any environmental pollution gas, then it will be prevented way. Okay, and like that way when earthquake come, then it will be prevented, because the environmental polluted gas it will be covered, number one. Number two, I will be incorporated for the energy distribution capacity like that of the in-plane and the outer-plane failure mechanisms in the both directions. Okay. Next is the sustainable design and with the green building concept. Okay, another examples for the solar system. So what is the green building? Right now the day is the for green building. Okay, what is the green building and how it will be function is the green building? Actually, what happened? Green building is the practice of the increasing the efficiency of the building and their ways and their use of energy, water, materials, and reducing building impacts on the human health and the environmental conditions through the better sitting, design, construction process, operational like that way, maintenance and removal system, which is taking into account every aspect of the complete building life cycles. Okay, so these are the beginning can lead to the three tops. First one is the reducing operating costs, that means cost efficiency or dot of the are going. Next is improved public and occupant health due to the improved indoor air quality system is there. And next is reduced environmental impact, that means environmentally polluted gas, carbon dioxide like that, it will be reduced or not. Okay, so these are the basic functions for the green building concept. Okay, so architecture who is essential and arena for the sustainable innovation. Okay, so what is the definition of the arena? Actually, our homes are one of the most important assets of our lives, which are worldwide needs help gaining popularity on that of the list. With the help of sustainable architecture, a green design can successfully meld beauty and functionality, which is all together to save our planet from the other resources. Okay, next is increase of the population for the day by day. Clear? So that's why requirement for the more to more building and more to more green building, more to more environmental impact. Okay, next is people migrating from rural areas to urban areas with the lack of the advantage. Okay, so people going to like that way. Next is replacement of the natural resources, that means solar system, it will be not implemented for the exact way for the rural areas. So the people converted from the rural to urban. Okay, high energy and natural resources are consumed due to huge populations, effect of the biodiversity. That's why the biodiversity park is to be incorporated for like that way. In our West Bengal, for Digha biodiversity park is ongoing process. I have incorporated on that project also. Okay, and if we right now I am working as the GH Rajuni College, that means Nagpur. Here the two biodiversity park is there. Here the energy to be conserved for the building, and the building get more efficient with the technique of the retrofitting technique. If you go for the wall flat, this is a migration. That means I have already discussed. First, the wall is flat. That means a crowded wall is there for migration, rural to the urban areas. Okay, and for the high energy efficiency, it will be there. Clear? So next is the methods for achieving sustainable designs. Okay, what the people needs: economy of the resources. That means energy conservation, water conservation system is there, and for the materials conservation system is there. Here, energy conservation, that means how much energy it will be conserved. Okay, actually what happened? Actually, when the earthquake comes, the building it should be collapsed. Okay, so the load versus deformation graph I have represented here. Earlier slide also. So this load, how much load it will be there, that's the building deform. Okay, so this y versus axis is graph is plotted for the load versus deformation. Okay, if we convert it for the area of that of diagram, then energy, how much energy it will be distributed. Okay, so if maximum energy it will be distributed, then building totally crops. So with that help of take, we convert the minimum energy distributed. If minimum energy it will be distributed, that means your building is totally safe. So with that concept of the energy conservation, we might predict how much energy will be distributed. With the APM software like that tool, that means ANSYS software or Abacus software or LSDNS software. Okay, next is water conservation. Yeah, this is the very devastating population for the water. Next is material conservation. That means material to conservation. That means if we go for the rural areas, that means materials, it will be not exactly availability is there. But if you go for the urban areas, the materials obviously it will be availability. Clear? So these are the economically of the resources person. That means resources. That means energy resources is there, or water conservation is there, or material conservation is there. Okay, next is the life cycle design. That means what happened for life cycle design. Actually, life cycle design here, pre-building phase, Number 1 is there, number 2 is building phase, and number 3 is post building phase. Okay, pre-building phase, that means first we have to construct it, that is building in way. Okay, so we go for the site, we go for the layout, and we go for the how much quantity is there, how much client quantity is there. That means 2 bedroom, 3 bedroom, 4-story building, 5-story building. That is pre-building phase. Okay, next is building phase. That means when beam and column placing is there, and then is soil bearing capacity is to be there or not. And last one, last but not least, this is the post building phase. After converted the building, then the building zone, that means if you go for the earthquake zone, there are zone 1, zone 2, zone 3, zone 4, zone 5, like that way. Okay, so zone 1 to zone 2 earthquake heavy intensity is there, zone 2 to zone 3, zone 3 to 4, and zone 5. Okay, so which zone it will be placed? Okay, so earthquake resistant design of the building, it will be incorporated like that of the green building concept also. Okay, next is the human design. Okay, human design, that means you have to analysis for preservation of the natural conditions, like that urban design and the site planning for design of the formation concept. Okay, so how to achieve sustainable design? Actually, what happened for the energy efficiency? Okay, if you go for the right-handed building, so that's of the building for the small is to be good. Okay, that means small building, okay, it will be fine. But concept is that how much energy it will be distributed, or how much energy it will be incorporated. That's the main concept. Next, the passive solar design. Yeah, that's the very impacted. That means if you go for the study solar system, it will be there or not. If your system is solar system, it will be connected, then your building will be more safe. Okay, next is active solar design. Here the solar design is to be generated for the like way for active and passive, for the damping concept is there. Okay, so this is the another terms is there. Next is high levels of the insulation. Okay, for high level insulation material is there. If you go for the your building, if you go for the earthquake vibration, so the damping effect is there. So reducing for the damping effect, we go for the tune damper courses is there, free vibration courses is there. Okay, lots of damping prevention is there. We take as per your choice. So my suggestion is that tune damper vibration, if you take, then your building is be more safe like that way, because it can prevent the earthquake more than like any other damper, and it will be energy resources. That means if we close the energy distribution capacity. Next is thermal mass. Okay, again reminding for that portion. Next is ventilation. Yeah, ventilation is to be very important, because if your building is not properly ventilated, so the in air energy it will be not exited, and like that way your building total wind load. Actually, what happened for the wind load? Okay, for the actually these are the hilly areas. If we go for the hilly areas, so these are the badly affected for the wind load. Okay, because here snow load is there like that of the wind load, and for the external pressure coefficient and the internal pressure coefficient, it will be varies for the building. Then your building will be vibrated like that way. So this ventilation is to be converted. Next is efficient lighting. Obviously, efficient lighting is there. That's why people are take for the greenery building, that will be green building concept. Next is that for the waste management. Here, before going to the waste management discussion, I enlisted for the efficient lighting is there for green building. For the glass door is there. If total building is covered for the glass door system, that means many highest building, then maximum lights is to be incorporated, and how much energy it will be converted like that way. Next is the waste management through designing in the modular system, recycling the while building concept, and the gray water system is to be there. And next is low flow taps and the shower system. Okay, if you go for the flow taps, that means if your taps is there and water is to be converted, that means water is the sufficient like that way for the water demandable peoples, like that per capita per demand for that way one colony or one family is to be sufficient. Then waste management system is to be totally keep in mind that way. Okay, next is the building materials. I have always converted use of here the building materials. That means if you go for the any building construction, that means coarse aggregate is there, fine aggregate is there, brick is there, Fe 4 and 5, that means steel rod is there, if your building is situated in the urban areas, so definitely it will problem will created. But if you if you go for the rural areas, definitely problem will be created. But if you go for the urban areas, easily availability is there, availability acceptance rate is increased like that way the urban areas. Okay, so our intention, if we go for the reuse renewable energy sources, that means the building will be collapsed, then this collapse building, that means this retrofitting technique, how it will be incorporated for the newly designed building. If you do that way, so there's a lots of research is there like that way. The partial replacement of the cement, like that way, this is the recent trends in the researchers do the partial replacement of the cement. They are due for the geopolymer concrete, that means they are doing for the 20% flyers, 30% flyers, 40% reduce the system, and then the geopolymer concrete is formation. And that's the way. Next is the for reuse, for reusable for the concrete, for the with the help of the plastic consumption. Okay, so another resource person, the plastic. Okay, because the plastic are not discomposed. Clear? So this plastic, it will be incorporated for the plastic dust. Okay, and then it will be 20% replacement of cement, 40% replacement of cement, that means raw materials. Then it will be strength is grain like that of mixed design 30, mixed design 40, mixed design 50. So people are looking that way. So lots of researcher area is there for one way to another way. Okay, so here the main objective is the building materials. If your systems building materials, raw materials is to be incorporated here, then your system is totally safe. So availability chance is there. So that's the building sustainable cities is to be incorporated for the whole way. It should be there. Okay. Next is the main important terms, which are the main focus in our topic. How energy it will be converted for this seismic retrofitting techniques in the building defined. Clear? So here optimize building envelope. That means how much if building is if your building is totally collapsed or demolished, okay, so how much energy it will be dissipated, and this dissipated energy it occurred. Okay, so optimize building envelope. Okay, number one. Number two, minimize demandable through serious conservations and supply energy with maximum efficiency and using renewable sources. Like that way for the site microclimate. Okay, another example is energy conservations. Next is passive solar heating. Next is passive cooling and natural ventilation is there. Next is day lighting, and next is renewable resources system is there. Okay, so these are the 1, 2, 3, 4, 5, 6 terms. Keep in mind always for energy design for the strategy. When your building is to be designed like that way, we have to design our building more earthquake resistant, more wind load resistant. That's another example for the energy. It will be there or not. For the energy design strategy, it will be nowly incorporated because of the green building concept. So that's the site micro, energy conservation, passive solar system, passive cooling and natural ventilations, day lighting system, and renewable resources. It will be there or not. If your building is totally covered like that way, your building is more safer like that way for the control building. Next is spectrum. Actually, what happened for the spectrum? This is the traditional vernacular sustainability by the default, which is existing architectural made, which is more sustainable construction. Clear? Next is the environmental determinism is there. Next is symbiotic relationship with the natural environment. Okay, so here the figure is there for symbiotic natural environment. That means one natural resources is to be connected for like that way. Okay, so that's to be incorporated in your building. Efficiency is there. Okay. Here, first one is the indoor environmental quality. Clear? If you go for the for right side of the picture, they are very comfortable. Why? Because conventional standards suggest of the optimal. Change is the natural state of the affairs building. Okay, and this totally covered for the glass door system. If you cover totally glass door system and the door systems for window systems, okay, and it will be people are more forgiving of the buildings which offer more control system. And when building vibrating is there, that means when building is vibrated, some tune damper courses. Okay, if you go for the actually what happened for the many vibration system, it will offer for the China, because these are the more earthquake resistance zone is China is there. Okay, so they are all high-rise building collapse. Sorry, they are more high-rise building prevented like the tuned damper courses. Actually, what happened here? When earthquake come, in plane outer plane failure mechanism I've already discussed. So the building is vibrated. Here the tuned damper course is to be base isolation system is to be there for the soil structure interactions and tuned damper courses. So the vibrating shape will be vibrated but remain same position after earthquake is come. So the dynamic environment simulates within the limits is not. Is that the cost question? Okay. So another keep in mind that question is ventilation is good or not, for air quality is there, and for the pollutants is to be incorporated or not. Okay, so next is the sustainable building materials is sustainable resources is there or not, extraction processing of the manufacturer, embodied energy systems, recycle maintenance system, emissions, and a procurement system. All are goes for the AMC, that means annual maintenance. If your building is created, your building is totally investigated for the maintenance. Okay, after 1 year, after 2 years, after 4 years, maintenance is there. Okay, if your building is not maintenance, then definitely when earthquake comes, then your building is totally collapsed, or like that way you'll be totally collapsed. Clear? Next is sustainable materials. I have already mentioned which sustainable materials here incorporated here. Energy engineered wood. Okay, so these are the more easily bamboo reinforcement. Now the trend is bamboo reinforcement. Okay, so here use structural elements which are manufactured with a minimum amount of the high graded wooden systems. Next is sustainable lumber. Use certified sustainable lumber is there. Use fast growing materials like that bamboo flooring resources is there. Next is reuse wood, that means use recut lumber from that of the recently dismantled buildings or not. Okay, next is recycled manufactured materials is there, that means use materials manufactured with a high recycled content is there. Next is long life and long maintenance materials, that means long life long maintenance materials. If your building is totally covered, suppose your building is forget about the masonry building, that means load bearing building. Okay, if you go for the infill building, that means load bearing wall is there and for the beam and column portion is there. Okay, fine. Here the condition is there for FRP bar is used instead of reinforcement for the FE 415, FE 500, that means yield strength of the steel. Okay, so if replacement of the FRP bar, okay, or like the shape memory alloy SMA bar. Okay, so these are the more earthquake resistant, more earthquake prevention. But thing is that the SMA bars is the renewable energy sources. That means if when earthquake come, yeah, the building totally comes, but this renewable sources, that means the SMA shape memory alloy, it will be restore the building and again it will be created. But thing is that is the high cost. We are civil engineers, we always keep in mind this is the low cost technology or high cost technology. Yeah, per cubic meter, sorry, per cubic, not per cubic meter, per meter the cost is $200. Okay, so $200, you can imagine how much cost is there for SMA bars. So it will be not implemented here. But in China, in Japan, they actually the SMA bar is fabricated for the China peoples. They are incorporated in structural building, RC structure for the beam column junctions for all our replacement with the SMA bar, shape memory alloy. These are the renewable resources. From the energy, it will be converted. Solar energy, it will be converted for the like that way. There are some techniques there, but these techniques people not find like that way because China totally is hidden, but it is under process. China is not telling like that way. Many researchers do like that way, but not proper research is done for like that way. SMA bar, okay. So this SMA bar, this technology is highly conservated for the energy resource sources, okay. Okay, next is low energy material. Use materials that require minimal energy to manufacture, transport, and grow system. Next is recycled and alternative construction system is there. So here the strawberry reconstruction curve is there. Next is prefabricated panel wall and roof system is there. Next is post and beam construction. That means if you go for the structural deficient for the beam and beam column portion, so here we are always keep in mind the junction portion. That means beam column junction portion crack is initiated. for the infill building also. Okay, so here the junction portions, if we some wrapping is thermal insulation is there, like that epoxy resin for the FRP bar or any other materials, then your building will be more safer like that way. But if you use for this memorial way, definitely it will be earthquake resistant building. But thing is that this is the high cost, heavy cost per meter, $2,000 to $200 is there. Okay, so in our people's they are not easily acceptable because the high cost technology is there. But if you take, definitely it will get more advantage, like that research is look that way. Here, for the recycled materials, that means sustainable architecture often incorporates the use of the recycled or second-hand materials, like that way, such as reclaimed lumber and recycled copper. The reduction in use of new materials creates a corresponding reduction in the embodied energy system, which is embodied energy, that means in the production of the materials. Okay, so how much energy to be dissipated? That's the very important factor. Next is often sustainable architects, which is attempt to retrofit the old structures to shiver new needs in order to avoid unnecessary in development. Clear? Next is when older buildings are demolished. That means your older buildings or old building are demolished, or frequently any good wood is reclaimed or renewed and stone is flooding. Any good dimension stone is similarly reclaimed. Clear? Many other parts are reused as well, such as the doors, windows, mantles, and hardware systems, reducing the consumption of new good system is there. When new materials are employed, green designers look for materials that are incorporated for replenished, such as the bamboo reinforcement materials. I have already incorporated for the bamboo reinforcement. Okay, so I have one project in Birbhum district. Okay, so see Birbhum in our West Bengal, for Birbhum, for like that Shuri, one complex is there. Okay, so it will be very famous person for the Birbhum, Mr. Kamal Khan. So one famous cinema hall is to be there. Okay, and their technology is the bamboo reinforcement is there here, replacement of the for the traditional for the steel structure. Okay, so some portion, some 2 or 3% it will be there. That means we have to test it how much it will be implemented or not. Okay, so like that building is there. Okay, if you go for the like that way for the Shuri, definitely so for the Shuri of Sudi bypass road. Okay, we're connected for the SBSTC bus connected. Okay, yeah. When new materials are employed, for the green designers look for materials that are always recomposited, such as the bamboo, which can be harvested for commercial use after only 6 years growth, sorghum of the wheat straw, both of which are waste material that can be passed into the system, or cork oak, in which only the outer bark is removed for that of the use and thus preserving the tree. Next is existing building can remolding. Okay, so always keep in mind that existing your building that can be remolded or not. That means maintenance is building is definitely there. If you maintenance your building after 5 years, okay, not only possible for the 1 year, because it is not possible for every time after 1 year it will be a maintenance or not. Okay, but every after 5 years, if your building is totally maintenance is going on after 5 years, definitely your building is totally more safer and more earthquake resistant also is there. Okay, next is renewable energy generation. Okay, so here the recent term is the some concept is there how energy it will be converted for the renewable energy and it will be generated for their system. So we are or knows 2-3 terms is there. First one is solar panels. Okay, so active solar devices such as the photovoltaic solar panels, which is held to provide for sustainable electricity for any use. Like that way, electrical engineer, their give electrical output of a solar panel is dependent on the orientation, efficiency, latitude, and the climate system. Solar gain varies even after the same altitude. Okay, roofs are often angled toward the sun to allow photovoltaic panels. Okay, their photovoltaic panels is the better implement here to collect at the maximum efficiency. In our if you go for the Tiruvananthapuram temple in our India, for the Hyderabad, like the Andhra Pradesh, definitely it will be there. Okay, solar panels can produce adequate energy if aligned within 30 degrees of the south. It will be incorporated here. Next is the wind turbines. Yeah, so like that way for the wind turbines is there. The use of undersized and wind turbines in energy production in sustainable construction structures requires the consideration of the many factors. In considering cost, they are invented for the expensive, then larger wind tunnels is there. Okay, so these are the systems is with there. Okay, here the more expensive than larger and turbines relative to the amount of the energy system they produce. Okay, building integrated wind turbine system performance can be enhanced with the traditional system. Yeah, next is solar water heating. Yeah, so right side, if you go for the solar water, okay, so here the water is to be converted for the solar energy, also called for solar domestic hot water system, which is can be a cost effective way to generate hot water for the room home. Okay, they can be used in any climate system, and the fuel they use sunset system is free. Solar water heats, also called for solar domestic hot water system, is there. It can be a cost effective way to generate the hot water for the home. They can be used in any climatic conditions, like that way. If you go to hilly areas, definitely it will be there. Okay, and any environmental condition. Okay, so they feel the use the sunshine is very free. Here there are always two types of the circulation: direct circulation systems and for the indirect circulation system is there. For direct circulation system, loop that domestic water through the panel system, and that for the indirect circulation loops glycol or some other fluid through the solar panels and uses a heat exchanger to heat up the domestic water system. Next is heat pumps. Here, if you go for the right side of the figures, air source heat pumps are inexpensive relative to other heat pump system. However, the efficiency of the air source heat pumps decline when the outdoor temperature is very cold or very hot system. Therefore, they are only really applicable in the temperature climate condition is there. Okay, so other types of the heat pumps are water sources, and it will be investigated in the air condition is there. Okay. So next is the types of the green and sustainable buildings. Here, all our buildings are go for the greenery building. They are covered to like that way in your home also, in your school building system is there. Commercial building and public buildings all are go for the green system building. In our some laboratories is there. Okay, if you go for the IIT Roorkee, okay, some development is there for the Hydra lab is there. Okay, and they are the very green system is there. Okay, next is healthcare facilities, sustainable building examples. In our India, there are lots of sustainable building examples as there. First one is C. Sorabaji Godrej Green Business Center, which is situated in Hyderabad. Clear? In our Kolkata, Infinity Benchmark, Saltlake City is the like that is the Kolkata is the green building system. Next is the Switzerland One Earth Pune system, Patni Knowledge Center Noida, Great Lakes Institute of Management in our Chennai. Okay, lots of examples is there. Okay, so here the examples of the Hyderabad in our Kolkata for Infinity Benchmark system. Okay, which is also inaugurated 2009. All of people are all familiar with the Infinity Benchmark building. Okay. So I have go for the next is the Knowledge Center for the Noida. Okay, this is Patni. Next is the Great Lakes Institute of Management for the China. Sorry, for the Chennai. Next is ITC Royal Gardenia, which is situated in the Bangalore. Okay, so these are the all our concepts for like that way systemic retrofit innovation strategies with the help of energy resources like that way for the energy building. Thank you very much for keep patience. If any questions your sides.
Thank you, sir, for your very informative session regarding the building materials and various areas of renewable energy sources to be used in building. I would like to request participants if have any questions regarding this session, you may feel free to ask. For the participants, if you have any questions regarding this session, Sir is available with us. You can ask.
Okay, you may ask in letter also. My mail ID is there and contact number is there. If any question is asked, please letter also will be there. Okay.
Okay, sir. I will provide it in the chat box, your mail ID.
Yeah.
If any participants have any questions, they can directly mail up to you, or participants can also write it up in the chat box. We'll forward it to you. Okay, once again, thank you for your very interesting session. In the future, we hope that we will get up any help And
Definitely, I'll be there, sir. I'll be there. Definitely,
once
sir.
again, many thanks.
Thank you, sir. I just one or two, three photos is there. Sir, please keep one or two, three photos and then send back to me for academic purposes. So please, yeah,
Okay, sir. We will send you the total drive link of the recorded video.
yeah.
Okay, sir. Thank you.
Yeah.
For participants, you have to fill up the feedback link which is available in the chat box. To get the certificate, you should require to fill the feedback link for each sessions. And the feedback link is only available in the chat box. It will not be available in the WhatsApp group. Our next session will start from 1:30 p.m. And we will start the third session of day 2 from 1:30 p.m. So see you right there. Thank you all.
Thank you. Right now, I am leaving. Okay. Yeah.
Okay. Okay.
Thank you very much.
Hello. Hello. Hello.
Yes, sir. Wait.
Shiv Shankar, सुनाई दे रहा है ना?
Yes, Sapanda. You are audible.
Hello, sir. You are audible. You are audible. Okay. Very good afternoon to everyone in this group. We are going to start our last session of today's program. Warm welcome to all the participants and our respected speakers, sir. In this session, our respected speaker is Mr. Swapan Ojha, sir. He has been working as a control desk engineer in Tata Power for 14 years, and Mr. Shiv Shankar Panda, sir. He also has a lot of experience for 11 years in Tata Power and maintenance. He is acting as a lead engineer in this company. Our Shiv Shankar sir will assist Swapan Ojha sir to give a valuable talk. Hopefully we will enjoy this informative session. Now please, over to you, sir.
Thank you, sir.
Sir, you are welcome.
Okay.
Panda,
Thank
can
you
you
so
share?
much. Yes. Yes, Sapanda. Just a minute. I am sharing the screen.
Okay, okay. Now it is visible. Good afternoon to everybody. As sir already told, myself is Safan Oja, and I have a qualification of diploma in electrical engineering, and then doing postgraduate in thermal power plant operation from NPTI, and also completed the AMI. I have almost work experience around 11 years at thermal power plant operation area. Today, as per the subject of discussion, I will try to deliver it, use some basic of the energy source. As I told, I am working as operation engineer. Lecture given for 1 or 2 hours, but it is, I will try to our level best. And most of us discussion are covered from Tata Power Energy Network, where you can take the knowledge of renewable source also. And as you want, give some introduction about you. Others will continue.
Yes, Sapanda. Thank you. Good afternoon to all of you. Sir, myself Shiv Shankar Panda. I have joined Tata Power in 2010, and since then I am working in. Earlier I was worked as a production engineer, operation engineer in operation department. Then I got transferred to mechanical department. Now I am working for maintenance of steam turbine, fans, compressor, pumps, like this, sir. And I am having total 11 years of experience. Thank you, Sabanda. Now we will start the presentation.
Okay. Next slide.
Screen is visible, no?
Yes, yes.
Okay.
Okay, sir. Please repeat once. Hello.
Yes, yes. First of all, you are all aware that the pandemic situation that is going from the last 1 year and over 1 year COVID-19 situation. So I'd like to go through some highlight that our company has taken to continue the service, like an uninterrupted power supply, and employee connection through online Microsoft, and family vaccination status, healthiness awareness session is already conducted. Employee healthiness and safety measure, technology adoption, as I told, through the Microsoft team. Medical support service is also available. Emergency response task force is created. Employee communication and defined policy has been taken. Here you can see from the slide that a number that is given by the meal supported by donations, and the masks created and distributed by Dhaga, employee contribution, 1-day salaries, and different initiatives have been taken by the company of these situations. Next. Now from the next, from this slide, that is our hero. Had some responsibility to give an awareness by the slogan, stay at home for us, stay at work for you, message from the engineers. Next. Now renewable, what is the, I'm coming different topic from this picture. All things are not written here, but I go through of this one by one. Now, first of all, we know all of these things, but what is now the renewable energy? As per our understanding, renewable energy is the energy from the source. Renewable source are the virtual, is duration, but limited in the amount of the energy that is available as per time. The major type of renewable energy source are the biomass, hydropower, geothermal, wind, and solar. And there is a category in the biomass, that is biomass produced through the wooden and wooden waste, municipal solid waste, landfill gas and biogas, ethanol, and biodiesel. And the next. Now, converting biomass to the energy. Biomass is converting to the energy through various processes, including, direct combustion, burning to produce heat, the thermomechanical conversion to produce solid, gaseous, and liquid fuel, chemical conversion to produce liquid fuels, biochemical conversion to produce liquid and gaseous fuel. Direct combustion is the most common method for converting biomass to useful energy. All of the, as you know, biomass can burn directly for heating, building, and water. And industrial process heat and generate electrical in steam turbine. Now, biomass is an alternative source of energy. Biomass being a product of a natural resource, land, water, air, sun energies, give much hope as an alternative, reliable, and renewable source of energy. Biomass is an organic matter produced by the plant, both aquatic and their derivatives. Plant material use the sun energy to convert atmospheric carbon dioxide to the sugars during photosynthesis. On combustion of the biomass, energy is released as the sugar has converted back to carbon dioxide. Thus, energy is harnessed and released in a short time of frame, making biomass is a renewable energy source. Though fossil fuels have also derived from atmospheric carbon dioxide, and the time frame is very long, in the order of millions of years as compared to a few years in case of biomass. Currently, biomass contribute, I think, 14% of the total energy supplied worldwide, and around 38% of the energy consumed in developing countries. Now, for the hydro energy, we are already aware that there is a potential energy source, that is reservoir, and water came from the intake, go through the penstoke and rotate the turbine, and there is a generator to produce the electricity. Panda, don't change the slide. Hydroelectric power is the electricity produced from the generator driven, as I told, by turbine that converted the potential energy of falling water into the mechanical energy. Hydropower projects are classified as large and small hydro projects based on their size. In India, hydro project plant of 25 megawatt or below capacity are classified as a small hydro and come under the review of Ministry of New and Renewable Energy. And there is an equation, as you all know. I am not go through how the power is generated, but P equal to G, Q, and HN. For small hydropower, India has a history of about 120 years of hydropower. The first hydropower project of 130 kilowatt commissioning in the hill of Darjeeling, I think in the year of 1897, marked the development of the hydro project in India. And now the time is for the in Mysore district, I think in Karnataka, 1902 for supply of power to Kolar gold mines. Following this year, there are a number of small hydro projects set up in various hill area of the country. Till the independence, 1947, the country had an installation capacity of 136.2 megawatt, in which including 508 megawatt hydro project. Depending upon the capacity of the project, a small hydro project can be classified as micro and mini and small hydro. Micro, I think, up to the 100 kilowatt, and mini 101 kilowatt to 2 megawatt. And the small hydro project, I think 2 megawatt to 25 megawatt. Now coming to the large hydro power. In India has an estimate hydropower potential 1,45,320 megawatts, excluding small hydro project. Several hydroelectric projects in India are delayed because of the environmental legal issues and the local disturbance, financial stress. And cabinet now, the Power Ministry of India now approved a large hydro project to be declared as renewable energy. Only hydro project less than 25 years are categorized as a renewable energy. And the all tariff from the hydro project are all are fixed from the Ministry of Powers. Now coming to the small point of view of wind power. Now the technology, the use of the wind as renewable energy involves the conversion of power contained in the message of moving air into the rotation set, as we all know. The conversion of process utilize aerodynamic process that can be lift or drag to produce a net positive turning movement of a shaft, resulting in the production of mechanical power, which can be converted into electrical power. There is a simple calculation formula: P half PAVQ into Cp, where P is the density of the air and V is the wind speed, and A sweet area of the blade through which the wind blow, and Cp is the efficiency of the conversions. The wind speed therefore play a vital role for energy generation, as there is a no linear relationship between the wind speed and available power. The energy content in the wind at different region varies with the latitude, land, sea deposition, altitude, and station. In India, the sector which mostly govern the availability of the wind at a particular site, it is a geographical location with respect of the monsoon wind. The availability of the data of wind speed being a basic requirement for determining of the flexibility of wind power generation at site, and due to the highly uneven distribution of the wind over the country, an assessment of the wind resource over different region was undertaken before any plan of harnessing the wind energy were drawn for implementations. Now coming to the solar point, solar energies. Solar energy is the most abundant and cleanest energy resource on Earth. The amount of the solar energy that hit the Earth's surface is an hour is almost the same as the amount required by all human activity in a year. Solar energy can be used mainly in three ways. One is direct conversion conversion of sunlight into electricity through the PV cells. The two other being is concentrating solar power, that is called CSP, and solar thermal collector for heating and cooling, that is called SCH. In India, endowed with abundant solar energy, in which capable of producing 5,000 trillion kilowatt of clean energy. Country is blessed with around 300 sunny days in a year, and solar isolations of I think 4 to 7 kilowatt hour HP per square meter of the day. Now some highlight of the solar PV technology that I go through. Solar PV cell, that is converted solar light directly to the electricity, and there is an crystalline silicon is the oldest technology for solar PV cell, and that is the short form. It is called CSI module, are subdivided into two categories, that is SC and SI, and the NC and SI, that is the thin film. A thin film is a newer technology in comprising of the crystalline silicon. They are subdivided further into three main families. Now, solar thermal technologies, coming to the point of solar thermal technology. Solar energy is used as heat source for heating purpose of direct use and to generate steam for generating electricity to the turbine. Different technology for solar thermal power plant making as of a concentrating of solar energy system. That is a parabolic thought solar tower, that is central receiving system, and the linear fractionless. Now, parabolic has the property of focusing the incoming radiation as it is focused. Working on this principal, linear concentrator of a parabolic shape are coated with highly reflected material and can be turned in a angular movement toward the sun position and concentrate the incoming solar radiation into a long receiving absorber tube. A working fluid is used to transfer the absorbed solar energy, which then piped to an exchanger or a conventional conversion system. Parabolic thought through system cannot make as a diffused radiation as they use only direct beam sunlight and require tracking system to keep them focused toward the sun and best suited to area with highly direct solar radiation. Now, what is the solar tower? Central receiver system use heliostatus of to track the sun by double axis mechanism, following the elevation angle with the purpose of a reflect the sunlight from many other oriented around a tower and concentrated in toward a central receiver tower. Now there is a mechanism of a floating solar, as you have, I think, but there is a floating solar PV installation open up new opportunity for selling of the solar generating capacity, especially in our country with high population density and competing us for variable lands. They have certain advantage over land-based system, including utilization of the existing electricity transmission infrastructure and hydro power site, close proximity to the demand center in the case of water supply rivers, and improve energy yield thanks to the cooling effort of water and the decreased pressure of the dust. The exact magnitude of this performance advantage has yet to be confirmed by the larger installation across the multiple geographical areas. The general layout of a floating PV is similar that of a land-based PV system, other than the fact that the PV array and often the inverter are mounted on a floated platform. The direct current DC electricity generator generated by the PV module is gathered by the combiner box and converted to alternative current AC. On the next. Now coming to the domestic footprint. At the beginning, we discussed small profiting of different green energy working principle, not in depth, but as per my understanding, you all know the theoretical better in depth, but what I want to deliver to you that after getting different technology intervention, we invent solar, wind, hydro, thermal segment for power generation. But here is a big question: how to invest? How will invest first to prove the technology to produce power. So here is a required some intervention of the market player. For us, Tata Power is one of the largest player, and also there is a market of Adani also capture some market extent. Here is just I want to share the knowledge-wise capacity. Here you can see from the slide, hydro, renewable, and T&D. There is the current capacity of Tata Power that is acquired in this Indian market. On the next. So before one slide, there is a point of microgrid. आगे जाओ yes. There is a point. Next आगे वाला आगे और आगे नहीं ऊपर 5 number slide. Yes. Okay. There is you can see from this slide there is a concept of the microgrid. Just a small talk on this matter. A microgrid. What is the microgrid? A microgrid is a group of the interconnection load and distribute energy. Resource within the clearly defined electrical boundaries that act as a single controllable entity with the respect of the grid. A microgrid can connect and disconnect from the grid to enable is to operate in both grid connected or island mode. To meet the electricity demand of its user, a microgrid must have an generation source. Given that microgrid are older connect, the electricity supply to the microgrid has an historically been from behind the meter. Fossil fuel generator, gas powered generator, for example. However, with the falling cost of solar, not to mention the environmental benefit of switching from the fossil fuel generation to solar power, many of the microgrid being designed today supply electricity with a combination of the solar plus battery storage system. Now, some advantage of the microgrid as provide efficient, low cost, clean energy, improve the operations and stability of the regional electric grid, critical infrastructure that increase reliability and resilience, reduce grid congestions and peak load, enable high efficiency, and use local energy resource and jobs. And a microgrid can be provided by the distributed generator, batteries, and renewable resource like solar panel, depending on how it fuel and how its requirement are managed. A microgrid might be identified. A microgrid not only provide backup for the grid in case of the emergency, but can also be used to cut cost for connection to a local resource that is too small or unreliable for the traditional grid use. A microgrid allow communities to more energy independent and in some cases more environmental friendly. Next. Now, the Tata Power has 2.0 transformation growth. Now, what is the 2.0? You may have some knowledge from the different news, but not mandatory. Okay, I will give you some key point on this. You all are aware that at a present day, we are going to facing the shortage of the coal. Yes, you might maybe know coal shortage. So at present day, should we think for different renewable source of energy? Here is a question for the we are identifying different source of renewable energy, but there is a question of sustainability of any industry. At the point of thinking, Tata Power has been taken transformation by taking consideration of the solar, hydro, wind, and at a large range. Here is 2.0 is an 3D concept, that is the digitalization, decarbonization, and decentralization. I will explain it in the later. Now come to the next. Here is in for the sustainability that I have already told. Different initiative has been taken by the any companies to sustain their business. As I told earlier, company has taken the initiative transformations in the portfolio from 30% green energy to cover up to 60% in FY23. Next. Now this is for an general knowledge purpose only. There is a capacity that have Tata Power. In Mumbai region, there is 930 megawatt thermal, that is, and Mumbai Hydro is 447 megawatt. Next, and we have in Gujarat Thermal Power 4,150 megawatt, and Maithon Power 1,050 megawatt. Jamshedpur, that is Tata Nagar 428 megawatt, Haldia 120, Kalinganagar, that is Odisha 375 megawatt, Bhutan we have a plant 126 megawatt, and Prayagraj 198 megawatt, and there is a plant of Georgia, that is South Africa 120 megawatt. Next. Okay, there is a renewable source. Now I just want to provide some information about the Tata Power Renewable Source Limited, that is called the TPREL, which is an 100% subsidiary company, and it is a generated portfolio 1440 MUs. FY19 last year, that is the figure out. Tata Power has the largest integrated power company. Today announced that the company's 100% subsidiary, Tata Power Renewable Sources, increased its generation capacity by 337%. And TPRL is the primary vehicle through which Tata Power investing in the renewable energy capacity are driven. TPRL is the purpose to growth in capacity through the organic and inorganic means over the next years, and completed commissioning of 100 megawatt wind farm at Andhra Pradesh, and 50 megawatt at Gujarat, and 15 megawatt also Telangana. And the MD has already said that we aim to create a focused renewable energy business through the TPREL, which is sustained growth and increase in our generation capacity in testament to our hard work in ensuring and increasing our operational efficiency. This achievement give us confidence to further make progress in the renewable energy sector. We will continue to look for the opportunities to acquire operation wind and solar plant apart from our own organic growth pipeline to grow our generation portfolio. During the financial year of 18-19, Tata Power Renewable Energy Limited completed the acquisition of the WREL in 1140 megawatt of renewable energy capacity on the international front. Tata Power South African joint venture company Georgia, as I already told. Next. Now the growth in the solar. Okay, I go through the part by part, manufacturing and rooftop and farms. Okay, growth in the solar. Tata Power Solar India, the largest integrated solar company and a wholly owned subsidiary of the Tata Power, has received letter of award to build 210 megawatt of solar PV project for NTPC. The total order value of this project approximately, I think, in INR 686 crores. With the addition of the order pipeline of the Tata Power stand at approximately 2.8 gigawatt with an approximately value of 13,000 crores. Thereby, it is not. The scope of the work include land, transmission, engineering, procurement, installations, and commissioning of the solar project. Seeking on the achievement, our MD said we are pleased to announce the new win of the large solar ECP contract from the NTPC. Tata Power Solar is the leader in the producing solar energy across the country, and this further validate Tata Power Solar excellent execution skill in the solar project. Over the year, the Tata Power has been Indian leading solar rooftop ECP player, will compelling economic, especially for the commercial and industrial segment. Favorable government policy and increased environmental awareness have been the key growth drive. Tata Power Solar comes with a successful background of execution large number of projects such as 250 megawatt and 50 megawatt in Kerala, 56 and 30 megawatt power plant in the Odisha. Now coming to the point of the rooftop. Tata Power Solar commissioning 820 kilowatt, the cricket club of India, that is Mumbai, in 100 days. The stadium was inaugurated by the Ministry of the Maharashtra. Tata Power Solar joined hand with the Cricket Club of India to utilize the potential of the solar energy. The installation of the solar rooftop project helped to generate over 1.12 million electricity per year, which lead to 25% of saving of the power consumption of the cost. At present, on an average, apart from the stadium flood light, which run on DG, the stadium consumes 4 lakh kilowatt per month. However, which the new solar installation on an average basis, the consumption from the grid would fall to approximately 3 lakh kilowatt per month. Now to the solar pump. A solar pump is the application of the PV technology, which converts solar energy into electricity to run the pump system, thereby replacing erratic grid supply and pollution caused diesel powered variation. The solar water pump is powered by the solar module that helps draw surface and groundwater out from the irrigations for irrigation. Tata Power Solar offer both AC and DC range of solar water pump in both surface and submersible categories. These pumps help reduce farmer dependency on expensive fuel and their maintenance costs as opposed to conventional irrigation systems. By switching to solar pump, farmer can have access to a highly efficient power supply that can be used throughout the day, providing a constant water supply. Over 50,000 pumps installed across India till date. Our goal is to provide water assurance and financial security to all farmers in India. Now coming to next. There is a concept of push the solar water pump 13x growth to top line. From this slide, we can easily understand the growth of the renewable sector by utilizing of the resource. And this is achieved because by the trust over 30 plus years of manufacturing, of experience, and a strategic tie up with operation and maintenance team, stabilized supply chain, and standardized of design, digitalization of operation excellency. Do you have any idea of the digitalization? I think, okay, I will go for that. For the plant operation day to day, and to sustain the business, and to easy and to reduce the man for working hour, we have taken different digitalization initiatives at Tata Power that help us to continuous improvement and to engage the right manpower in the right direction by analyzing different data, by using different tools. That is different by taking different of this initiative, how it is actually going on and what are the advantages. Next. Now, this is for your reference that how it is work the solar farm for the farmer and how does it work. Next. Now just want to give some solar system, how it is working. A solar rooftop, that is rooftop. A solar rooftop system typically consists of a solar module, solar inverter, and other electrical component as meter, cables, etc. Any excess electricity generated is exported to the national grid, and owner account is credit accordingly, subject to privileging regulatory policies. There is an I said there is a solar module converting sunlight into the DC electricity. Inverter convert DC electricity into AC electricity. There is a metering system, measure how much power your premises use, and any excess power that solar system feed to the grid. Now there is a national electricity grid, and they have some their policy electricity supply. The capacity of the solar installation depend upon the load requirement. You want to power through the solar, quantum electricity bill varies from state to state, and average approximately 1 kilowatt system is required for an 1000 electricity bill per month. Next. Here is a three. As I told, there is a 3D concept, that is decentralization and decarbonization and digitalization. By taking of these different the digitalization initiative, now the market size there is some showcase of the capacity wise of rooftop solar farms, and there is an initiative that is taken by the company, that is electric vehicle charging, and it is the current business that is going on large scales, and the market size of the solar rooftop is expected to be 30 gigawatt by 26, and solar farm, as I already told, 19,500 crore. It is the target in the rupees, but it is an if I converted into a news, that is 300 plus in the they are installed the farm. Next. Now renewable energy, renewable industry driven by already, I think I have already told the decarbonization, decentralization, and digitalization. Energy decarbonization has boosted the sector due to the continuous entry of new energy sources and new player in the electricity market. note here is the entry of variable energy renewable generations of solar PV on land and offshore wind, which have been to replace a conventional form of generation. In addition, electricity system in the future will have to consider other factors such as smart transport and service, which will not be liabilities but participant and asset that will become quick and real-time booster of this system. The new technologies challenges both of the investment in the conventional energy, that is hydro, natural steam, thermal power plant, among other, who's looking in a place of different energy context with a different price from today, as well as a new form of energy production. The context has changed and has often been, for an example, when renewable receive significant economic insufficient to encourage their production. This influenced and changed the revenue flow of project, which depend on the each country's models and payment terms. Another energy regulation is the decentralization of the energy source. As wind, solar, and storage technology have more competitive investment cost, they will become more affordable, and therefore there will greater preparation of the distribution generations, which would be also taken into account as per their this new power system. In this new electricity business model in the distribution segment, where user and consumer are no longer energy, the recipient, they now become more dynamic approach and are not only able to deliver energy but also to choose and buy cheaper energy on a variable business intraday or in a period of the time. This is because of the customer now have to, the possibility to install distribute energy resource, making them more informed consumer who can see and analyze production and consumption from their computer. Now, consumer become more proactive, as I told, and thus will push an energy marketer or the distributor to find new way and product to attract customers. Furthermore, distribution network and operator will also have greater investment needs, whether in reaching infrastructure, housing installed, and adoption of electricity installation, integration, self-consumption, smart meter also take place and vital role. This is the dynamic that we will govern electricity power systems, which although will provide service adapt to technology development in the society, which also bring about the issue to resolve, and that specialists and other stakeholders promoting the investment should address and take into account. Next. Now here is the some figure out of the renewable capacity. From this slide you can easily visualize that which position is acquired, and by this we can easily understand that the renewable source increasing in a rapid manner, and company has taken different T&D sector and collaborate with the IITs to increase our renewable resources. Next. There is also the green portfolio that from this we can easily understand the hydro is 28%, solar, and the thermal current positions. and not I am not go for the rupees values, but from this figure we can understand the exact value, and company has now taken the target for the green energies. And Panda, I am requesting to you give some overview of the thermal plant. It is the renewable also. Panda,
Yes.
give
Yes,
some
Sapna.
information about thermal Haldia power plant also.
Okay. Sir, so actually, especially there are no such slide. Actually, this presentation was for renewable energy, so I did not make any slide for the thermal plant in Haldia. In Haldia also, sir, I just want to say that Haldia is coming under green energy, as we are using the flue gas coming from Tata Steel. Actually, Tata Steel is making coals from the coke. Tata Steel is making coke from the coals by coke oven. So during that process, the hot gases are coming out from the oven, and we are just using that flue gas as a fuel in our boiler, and like that we are making the steam and we using in our turbine, and convert the mechanical energy to electrical energy, and so we are supplying the energy to the electrical energy to the grid. Actually, this plant is like this is coming under green energy, and initially the we are having total 16 numbers of boiler. So in and having 3 numbers of turbine, and two of them is capacity of two of them is 45 megawatt, and another one is for 30 megawatt. For the 16 boiler, all the boilers are identical, and for and the capacity of all boilers are 7.5 megawatt. So and that all the boilers are connected in a common header, and we are producing the electricity. And earlier it was planned to as a captive. It was a plan for making the captive plant of Tata Steel. But now that is not still that is not coming under captive plant. That is under in that is separately with Tata Power, and we are now our business module is merchant power cell, and we are giving the power to actually there was another company of Tata, that is TPTCL, Tata Power Trading Company. They are making the they are giving the tender to the open market for power cell, and whoever is L1 based on the lowest one and highest one, we are whoever will be the L1, they will get the order. Like this, we are selling the power to grid and WBCTCL. Okay, sir. Soma, sir. So, if any question, Sabanda, then we can go ahead.
Yes, that's all from our side.
Yes.
Now, sir, very much thank you for this informative session.
Thank you,
Hello.
sir.
Am I audible?
Yes.
Yes.
I am asking to every participant in this group now. Am I audible? Clear or not?
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you very
Yes,
much
sir.
to both of speakers, sir, for this nice such informative session. Now, I like to request our participant as well as the audience to, if you have any question, you can ask to our respected speakers, sir. Have you any question? Hello. Okay, sir. Thank you, and very good afternoon to everyone.
Okay. Thank you, sir.
Okay.
Okay, sir.
Thank you.
You're warm welcome. Enlightened our program very much.
Thank you.
Okay, sir.
Okay.
Okay.
Now, from our committee, we have information to convey you. Our session is over now, and our next session will start from tomorrow. Please join with us, and very much thank you for your kind cooperation. And one instruction is also required to give you. You have to fill the feedback form to achieve the certificate, and the filling the feedback form is mandatory for all of you. Okay, thank you very much.